Thank you for joining us today. I'm Chelsea Drenick, Regional Director at WoodWorks, and we are live from the Lendlease Product Development Center here in California. So welcome both online audience and our in-person audience. I'm really excited about today's event. This is my first hybrid event, so bear with me. And these slides are available on our website if you go to woodworks.org under Events Presentation Archive. This is also being recorded, and the recording will be available later, so all forms of technology here. So before I jump into the content of this presentation, I just want to say a few quick words about WoodWorks for those who may not know about us. We are a nonprofit organization dedicated to helping project teams design and construct wood buildings. So I do a lot of presentations like this, we do a lot of presentations like this, but our main focus is that we help with free wood design assistance to architects, engineers, and others in the building industry. So ask us your questions, bring us your challenges. So I am based here in San Francisco. I cover Northern California, Nevada, and Utah. And we have regional directors all over the country. And that's because we get to know our local codes, our local building designers, the local AHJs who are here with us today in person, which is awesome. So reach out, we are here to help. So a little bit more about me. I joined WoodWorks about 1.5 years ago. I am a licensed structural engineer. Here in the state of California, I received my BS in engineering from Harvey Med College, my master's from Stanford. And prior to joining WoodWorks, I spent 9 years in structural design consulting here in the Bay Area. And my design experience is in a variety of sectors, building sectors, residential, higher education, retrofit of existing and historic structures. And I'm really passionate about sustainability and the use of wood as a building material to reduce the embodied carbon emissions of structures. So the reason we can provide free wood design assistance, and Jennifer just talked about this in that video, is because of our funding partners. So I'd like to thank them, the Softwood Lumber Board, U.S. Department of Agriculture, and Forestry Innovation Investment. We also have a number of manufacturers that support us, so thanks to them, we get to know their products, we get to know them, and so if you're interested in learning more about any of their products, we have all their contact information available on our website. So we're talking about mass timber today, which is really exciting. We're seeing it really grow here in the country, and we've been tracking it. You know, that's one of the things we do. We track projects across the country, built and in construction, and you can see that exponential growth. You know, mass timber, it's an innovative material. It's an innovative material that's here to stay. So that's what we're talking about today, and that's really exciting. One other thing I want to mention is the WoodWorks Innovation Network. So all the project assistance we do is confidential, but we wanted a way for project teams to showcase their built and in construction projects. So there's a lot of amazing project photos uploaded. It's kind of like the Facebook of mass timber projects, I'd like to say. So you can go there and see what is built and in construction around the country. You can filter it now by location, building type, size, material, and more. So really a great resource if you want to see what's going on. All right, so this is an AIA accredited presentation. So if you provided your AIA number, you will get credit for that. We will submit that for you. There will also be a certificate of completion emailed to you if we have your email after this event. So here is our course description that is required for AIA and our learning objectives that were online. But I'd like to start with our agenda. What are we doing today? What are we talking about? So we're currently in the welcome and the mass timber introduction. That's me, Chelsea Drenick. And next we'll be hearing about the state of California's perspective on mass timber from Katie Harrell. She's not able to join us in person today, so that will be a recording. And after that, we'll hear about mass timber fire testing to establish tall wood code changes. Ray Obrockie, he also could not be present, but we do have an awesome recording. I did just watch that yesterday. It's very fiery, which is fun. Then we'll have a short break. And then we have Chief Greg Anderson here, who will be presenting on mass timber code provisions here in California, the adoption of the Tallwood code provisions in California. And then Bevan Jones will be talking about mass timber fire design. And then I'll invite our 2 in-person speakers as well as 2 other panelists up for a more casual conversation on mass timber here in California. All right, so this is our mass timber introduction now. What is mass timber? So mass timber construction, I like to think of the delineation between mass timber and heavy timber. So heavy timber, we're thinking of the historic method of construction, you know, a solid 8x8 column, a 10x14 solid wood beam. Mass timber can have these same sizes, but it's made up of a number of smaller individual members that are laminated together, either using adhesives, nails, screws, or another type of mechanical fastening. So here's a visual comparison I like a lot. Heavy timber on the left, mass timber on the right. So one of the old adages with heavy timber was large column, large tree, meaning every single large cross-section of wood had to come from a single tree, which can be hard to source. So if you have to have a 12x12 wood column, you have to have a tree that's larger than that. Whereas on the right, we can still have that 12x12 column, but instead of coming from a singular log, we can fabricate it from smaller pieces. So we can use commodity lumber products, perhaps even lower grade products using smaller diameter trees to still produce these similar sized elements, columns, beams, and panels. All right, so that's mass timber, that umbrella definition. Let's talk about some of the products. So glue laminated timber, glue lam, often are beams and columns in these buildings. You know, we've been using glue lams for over 100 years. We use them in light frame construction for longer spans, and now we're using them in these mass timber buildings exposed as our beams and columns. And then we have a lot of different options for our horizontal surfaces. CLT, cross-laminated timber, is probably the most well-known, and it's shown with solid sawn laminations in the center and structural composite lumber laminations on the right. So CLT, really cool product, and we'll hear a lot about it today. It's a two-way span system, which is awesome. So it can be point supported. It's kind of like, you know, concrete. So you can have post supports. Really big panels, think 8 to 12 feet wide, 40 to 60 feet long. Other options for our horizontal surfaces: dowel laminated timber, DLT, nail laminated timber, NLT, glue laminated timber, GLT. So all these products have their laminations running in the same direction. The difference is really how are those laminations connected. So dowel laminated timber, we have hardwood dowels connecting the pieces. Nail laminated timber, we have nails. And then glue laminated timber is basically a glue lam beam on its side. And really interesting products, different than CLT in the sense that, you know, these are one way, right? We don't have that two-way action, so they will be likely beam supported, as we see in these photos. Another thing we have to think about with these is all the laminations are running the same direction, so as moisture changes, the moisture content changes, they'll swell when it rains and shrink as they dry out. So you can see expansion joints in these photos between those panels. But otherwise, you know, these are all options for those horizontal surfaces with mass timber. Okay, talking about framing options now. Mass timber buildings, they don't all look the same. You know, we have an awesome demonstration building behind me. You can see some different options in there. Often we see post and beam shown on the left, kind of replicating those spans, the grid spacing of steel and concrete. You know, 20 by 20 grids, 30 by 30 grids, you know, glue lam, often glue lam beams to posts with those horizontal panels on top. Flat plate construction shown in the center. This is possible with CLT because of that two-way span action. And so no beams shown here. It is a tighter grid. I think this project this is Brock Commons shown in the center up in British Columbia. I believe the grid is 9 by 13. So really tight grid, more common for residential. We're seeing it used there. Honeycomb on the right, or house of cards style construction, where both the vertical bearing systems and horizontal decks are all mass timber. We also don't have to have an entire mass timber building. For multifamily, low and mid-rise, we've seen CLT floors with prefab panelized walls used very successfully. Basically replacing that floor system, it's not that simple, but replacing that floor system, the TGI joists, with CLT panels spanning to wood-bearing walls. Steel hybrid is also an option, and we've seen this in a lot of office projects, actually. So, you know, maybe this is the best fit for a project. All right, so CLT, I'm going to focus on this a little bit more and how it's made, since we're talking about this a lot today. So CLT, we're basically taking 2x, they're playing down, typically 1 inch and 3/8 thick in the end, laying them down, putting down a screen and adhesive, and then the next layer is cross. So that's how we get that two-way action. We usually have odd number of plies, so 3-ply, 5-ply, 7-ply. The reason for that is those outer plies are running the long direction, consider the major strength axis, and the opposite direction is the minor weak axis, going that short dimension of the panel. So unlike NLT, DLT, GLT, there is a strength in 2 directions. So this is showing a CLT press. Each manufacturer has a different size press, so slightly different size panels. They're also using different species, so different design strengths. With mass timber, it's important for project teams to involve manufacturers early on in the process, so these design parameters are settled on. And I have a short video here to show you how CLT is made. So we start with that commodity lumber I mentioned. The first thing they're going to do is finger join it end on end, so we can have these longer panels. You know, panels are, I'd say they're, depending on the manufacturer, 4 to 12 feet wide, 40 to 60 feet long. So those pieces are then cut to size. Each panel is made for a specific location on a specific project. So first they're going to get that layer of adhesive down on top of that first ply. And now that second ply is going, that's cross. The diaphragm opening, or I think it's a window opening on this panel. And that third ply then gets installed. So very automated here in a factory. The last step is to go through the planer, and now we have a 3-ply panel. So CLT is all prefabricated. We're not going to a local lumber yard and saying I need 8 sheets of CLT. Now, it's something that's done for a specific project where you have specific panel sizes, you have openings, a lot upfront coordination. You know, everything's done in 3D, shop drawings, and very precise. You know, tolerances, 1/16, 1/8 of an inch for these panels. All right, we have some, sorry about that, some issues on the slide, but I'm gonna go through some project examples now, see some built and in construction projects focusing here in the Bay Area and also around the country. So one to Harrell, it's in San Francisco, 4-story office building, 130,000 square feet. They had a significant savings on this project because of the reduction in weight with mass timber. So they took building through design, pretty far through design, concrete and mass timber. It's in Soma that has poor soil sites, so they had to use deep foundations, and they were able to significantly reduce those by switching to mass timber because it's a lighter weight material. This is the Canyons in Portland. So this is a multi-family project, hybrid light frame and CLT floors. Really beautiful. I love to look at the photo on the right. You know, usually we see these double-loaded corridors and they're really dark and kind of sad. But here they were able to bring in that natural light and expose that wood to really make it beautiful. A local project here, Timber Quest. So mass timber typically makes sense on a larger scale. You know, we typically see them larger than this 3,000 to 9,000 square feet. But this is an exciting new prefab option here in California. Intended to be classroom, it is DSA pre-approved. It could also be a community center, other uses as well. The idea is to replace modular classrooms with higher quality, cost-competitive, sustainable solutions. Project 1 is in Oakland. This used CLT with the structural composite lumber laminations. So hybrid with light frame as well, and really cool project. You see that tight urban site. So no room for staging at all. I think they had an off-site staging area, and they're trucking the panels in place. They're also trucking the walls. They were all prefabricated off-site. So the contractor said it was originally all designed with light frame wood. There was a 14-month window for construction. When they used the prefabricated solutions, it was cut down to 10-month construction schedule. All right, so thinking about tall wood now. There isn't anything in construction yet in California. We have a lot of upcoming exciting projects in design, and maybe we'll hear about them later today. But there are some projects in construction around the country using the Tallwood provisions. So this is intro in Cleveland, 9 stories above grade, 8 stories of mass timber on top of a 1-story concrete podium. Really big project, over 500,000 square feet, nearly 300 apartments. It has some ground floor retail and events venue on the top floor. So this is one of the first projects to utilize the new construction type 4B with modifications. The City of Cleveland has not adopted the new 2021 IBC Tallwood code provisions we're talking about today. So the project did need to apply for an AMMR alternate means and methods request, looking ahead to the coming code. Ascent in Milwaukee is also currently under construction. When complete, it's scheduled to be the tallest mass timber building in the world. And it did top out in December 2021. So it's 284 feet, 25 stories in total. So it is a hybrid project. The first 6 stories are concrete, 19 stories above that are mass timber, and there are concrete cores that go all the way up to the roof. You can see those concrete cores on the right. Ascent is using a modified Type 4 approach. Along with the fire engineer consultant, they work closely with the city to express design project goals, aesthetics, and the safety measures taken. So one of the requirements they had was to perform the first 3-hour fire tests of glue lam columns, which they did at the USDA Forest Products Lab in Madison, Wisconsin. So they actually utilized some of the design requirements of Type 1A construction while incorporating mass timber. So how do we get our required fire rating with mass timber exposed like this? And this is what many of our speakers will be talking about today. I'm really looking forward to hearing about this more. But I did want to introduce it here. Wood, as it burns, mass timber, heavy timber in particular, it burns at a rate we can predict very accurately. It burns fairly slowly. As it burns, it's forming this char layer on the outside of the exposed surfaces. What that char layer is doing is insulating the inner wood, keeping it cold so it can retain its structural properties. So through numerous tests that have been done over the years, we can very accurately predict at what rate this char layer will form. So we know how much wood we have left given a 1-2 hour fire resistance rating. And it's approximately 1.5 inches per hour. And that's shown here in the NDS. All right, so let's take a look at lateral systems. Code process turns slowly. CLT shear walls are almost adopted. We do have R values in ASC 722, which has been published recently. And the NDS SPIDWIZ, our structural design provisions for wind and seismic, has prescriptive detailing and design procedures. Most designs thus far for mass timber are using other lateral solutions. So on the right, we have for mid-rise, multifamily, we often see light frame wood shear walls. On the left, with office buildings or taller buildings, we're seeing steel or concrete seismic systems. How are those panels connected together, to create that structural diaphragm? Questions that come up, particularly in California. There are a few different ways to do it. This is most common, this plywood splice or a surface spline detail. The manufacturer can leave a small section of each CLT out or remove a portion of it on the top side there. Then we're just installing the strip of plywood or thin veneer, nailing or screwing it down, tying that diaphragm together. So there are provisions in the new NDS structural design provisions for wind and seismic that will be adopted in the next code cycle. And I know project teams around the Bay Area and around the country are already starting to use these provisions, and fortunately they are being accepted. All right, so I talked about framing approaches earlier, and we've seen a lot of post and beam, around the country in different projects. So I wanted to talk about different options we have, and how different we can solve one connection. Left is fabricated probably by a steel fabricator designed by the structural engineer. Center, we have a proprietary connector. There's a number of manufacturers making these. And then on the right, we have just the beam slotting into the column. So they're all solving the same problem with different solutions. And we have to think about a lot of different things with how we solve this problem. How do we design for wood shrinkage? What are cost implications? What's our aesthetic impact? And then what we're focusing on today, how do we rate these connections for fire? How are they safe for this connection, particularly on these taller structures? So we're really fortunate here to have Bevan Jones from Holmes with us today to discuss fire design later on. All right, so acoustics, we're not really diving into the details on this today, but I do like to talk about it because it's one of the many things we need to think about in these buildings. The lightweightness of mass timber, it helps us for a lot of things like installation, reducing those foundations. It kind of hurts us on this acoustics. So we're going to be adding assembly on top of our panels. We won't just have bare panel. Part of that is because it's a softwood product, so it's not durable walking surface. So we're typically exposing that ceiling side, putting Acoustimat on top. There's a lot of different options for that. And then 1.5 to say 4 inches of gypcrete or concrete, and that can be your finished floor, or often we're adding in like another Acoustilayer and then the finished floor on top. All right, so the why of mass timber. Why are we talking about this here today? Why is it gaining popularity? And Katie Harrell will be talking next in a few minutes here about why here for California we want to use mass timber, why we want to increase its use. But I want to just kind of touch on kind of the overall topics. And it really, one of the main ones here is, we need more buildings, we need more housing, but buildings generate nearly 40% of annual global greenhouse gas emissions. 40%, that's a lot. That's what's shown here in the yellow pieces of the pie. 28% is building operations, 11% is embodied carbon emissions. So that's when a building's built, how much CO2 is released due to its materials and construction. So looking at this embodied carbon and operational carbon more closely, operational carbon is a bigger portion, but it takes 17 years for operational carbons to surpass embodied carbons. So we can have a real impact in the short term by reducing these embodied carbons. And I think the building industry is focused for a long time on operational carbons, but now we're looking at embodied carbon emissions more and more. How can we reduce them? Operational energy emissions are fortunately improving. Greener grids, more efficient heating and cooling. Embodied energy is not insignificant, and it doesn't have to be the necessary evil of building a new building. So what can help with that? Wood. Wood is 49% carbon by mass or weight. So 50% of this wood is carbon that was in our atmosphere contributing to global warming is now physically converted into solid form of wood and put into a building. So whole building life cycle assessments typically show wood buildings as a way to reduce the embodied carbon footprint of a structure. We do have a life cycle assessment that we recently released of a mass timber office building in Denver called Plat 15. So briefly visiting our forest carbon cycle here, I really like this image from USDA, and they have a number of great graphics to explain forestry and wood products. So life cycle of wood, it begins with growth of trees in a forest. Carbon flows into a forest ecosystem as a tree grows. Carbon is stored for the life of the tree. Left to natural processes, that tree will die and decay, releasing carbon back into the atmosphere. Instead, carbon can continue to be stored by using that solid material in buildings and building products. So throughout the life of a wood building, it's basically acting as a carbon sink, storing that carbon dioxide. One thing to note, it's only sustainable if the forest is sustainable, if the forest remains a forest after the tree was harvested. Here in North America, the forests have been very well maintained and stable for the last 100 years, and there are a number of regulations that ensure this. And that's something that Katie Harrell will be talking about more shortly, forests here in California. Another why for wood, for mass timber, exposing it, biophilia. So it's this innate human instinct to connect with nature. We feel good around wood. Studies have shown it. We also hear from developers of mass timber projects, they're seeing faster leasing and higher lease rates. And this is shown in our business case study that we have available on our website. Another driving factor is this why of mass timber is worker availability and shortages. It's existed for many years. It was driven really by the recession at 2008 and 2009 and never really recovered from that within the construction industry. So coupled with urban settings, we know labor tends to be very expensive here in urban settings. Mass timber is a way to integrate off-site construction. The crew on-site can be smaller. We are creating more jobs off-site in a safer work environment. And this point is tied to the previous. Compressing construction schedules will reduce the requirements of labor, requiring less time of folks on site. Time is money. Mass timber helps with this. It requires a lot of coordination up front, but when it gets to site, it goes up like a set of Legos or IKEA furniture. It goes up very quickly. So this is a feasibility study that was done on a 12-story tower in Seattle, comparing a concrete construction schedule to a mass timber construction schedule for the same project. And they determined there was a 5-month saving with mass timber. So that's our market drivers, the why of mass timber, and I think we'll be hearing more about some of these today. All right, so I'm just going to touch on the code briefly. We're going to hear more about the code from other speakers, but I just kind of want to introduce some ideas here. And a question comes up often, is CLT in the building code? People ask me that, and the answer is yes. First arrived in the 2015 IBC, 2016 CBC. It's defined in Chapter 2 as a structural wood product. It's referenced in Chapter 23 as an acceptable building material when manufactured according to the PRG 320 standard. So how tall can we build? So before the Tallwood code provisions that will be discussed more today, we are limited to 6 stories for a business office occupancy, 5 stories for residential, 85 feet. And that's with type 3, type 4, and type 5 construction types. Nice thing is we can add mezzanines. We can put it on a podium. So we do have options to make bigger buildings, but we wanted to go taller. So in 2016, Tallwood Ad Hoc Committee was created to explore it here in the States to push forward new code provisions. 5 full-scale mass timber fire tests in a multi-story apartment building were conducted at the ATF lab in 2017. And Ray Obrockie from AWC will be speaking more about these tests in depth in about a half hour. So given the success of the tests that we'll be looking at, the Ad Hoc Committee proposed 17 revisions to the IBC, and they were included in the 2021 IBC. All of them were passed. So we have 3 new construction types. They're under the type 4 construction type. So really didn't want to touch the existing type 4, so that became type 4 HT, type 4 heavy timber. And so now we have type 4 A, B, and C. And so we can see how tall we can go with this. So type 4A, we allowed up to 18 stories. Type 4B, up to 12 stories. Type 4C, up to 9 stories. So differences between these are really, increasing that fire safety the taller we get. So type 4C, type 4B and C have lower fire ratings compared to type 4A. And there's also this new concept of exposure level in mass timber. So how much timber can we expose? So these were adopted early here in California, and we have Chief Greg Anderson with us today. He's the Chief of Code Development and Analysis for CAL FIRE. So he'll be speaking more about the specific adoption here in California. I do like to share this quote from our State Fire Marshal, Chief Mike Richwine. He says, the early adoption of mass timber codes can benefit California in many ways, but I'd like to highlight 3. It has the potential to increase the market demand for mass timber production in California to meet the needs of the construction industry. It will increase the pace and scale of our wildland fire prevention and forest management goals of treating 500,000 acres per year by thinning the forest to smaller diameter trees that can be used in the production of cross-laminated timber and other mass timber assemblies. While wood products provide the benefit of storing carbon, another benefit or advantage is that mass timber construction can help reduce the carbon footprint of concrete and steel production. So quick intro now to what does California do differently here. I think we're all aware of this. The CBC has historically not allowed double dipping, as we call it, for sprinkler increases of building height and area for occupancies A, E, H, I, L, or R. And the IBC doesn't have the same restriction. Also specific to the CBC for multi-story buildings, the total allowable area is equal to the allowable floor area multiplied by the number of stories not to exceed 2. So it's for those same occupancies specifically. This value is 3 in the IBC. So what does that mean? For example, if we're using the sprinkler area increases, the allowable height in the CBC is 20 feet and 1 story less than the IBC limits for these new construction types, as with all construction types. So when we add sprinklers, we're going to be adding sprinklers. As we can see, no sprinklers were limited to 65 feet across the board for all these. Or then if we want to use it, mainly, we're really talking about residential often. It should say R down in that bottom one, A, E, H, I, L, and R. We can either take that height increase where we go 270 feet, for A, 180 feet for B, and 85 feet for C, or we can take that area increase where we lose 20 feet on that height and 1 story. So really showing what that means here. Let's say we take a residential building, we want type 4B. We can either take that area increase, so we lose that top story. We have 11 stories allowed, 160 feet. We have 123,000 square feet allowed per floor, but the max total building is 2 times that. So that's the big number there at the bottom, 246,000 square feet total. That's our total building area allowed. Or if we take the height increase, we get that extra story, extra 20 feet. in the code for this type 4B, but we can't then take the area increases. So we're really reduced there to that 41,000 square feet per floor. Multiply that by 2 for our total building area. The nice thing is, even with these tall wood construction types, we can add them, use those podium provisions, other provisions we have in the code. So we can take that area increase and we can put it on top of a podium if we want, but we're still limited to that 160 feet in height. All right, so that's all I have for you, this intro to mass timber. I would now like to turn it over to Katie Harrell. So I'll give her a brief introduction before we play her video. So Katie works for the California Board of Forestry and Fire Protection and manages the Joint Institute for Wood Products Innovation. Prior to her work with the board, she worked for UC Berkeley and the California Forest Pest Council for 17 years, addressing California forest health and invasive species issues. All right, thank you very much. Now over to Katie.
Good morning. I'm Katie Harrell with the Joint Institute for Wood Products Innovation and the California Board of Forestry and Fire Protection. I look forward to sharing with you today California's perspective on mass timber. To sum it up, California believes mass timber should be a part of the building and climate solution. We have a housing crisis in the state, climate change impacts, and a forest in dire need of restoration. Marrying building needs and forest restoration needs simply makes sense. For context, California has 33 million acres of forest land, about a third of the state. 60% is publicly owned and 40% is privately owned. 14% of the privately owned land is managed by the timber industry, who actively manages their land and keeps their mills near or at capacity. Additionally, our forests are struggling. Decades of fire exclusion have led to overstocked forests, making forests already stressed from overcompetition of resources. Now they have the added stress of drought and increased temperatures, resulting in increased rates of evaporation in the forest system and making trees even more water stressed. All this means bigger, more heat-intense stand replacing fires, which permanently alter our forests, resulting in less carbon sequestration, causing a loss of natural resources, negatively impacting recreation and the communities that rely upon that recreation economically, resulting in wildlife habitat loss. Also, the smoke impacts millions of Californians in both urban and rural communities and adds massive amounts of climate pollution into the air. These megafires threaten our water supply as well. 60% of California's water comes from the Sierra Nevadas. These megafires create increased runoff, decreased water retention, and lead to water contamination. Stressed forests also lead to increased bark beetle populations. Increased temperatures, overstocked forests, drought, megafires have all led to native beetle populations no longer being kept in check. Tree distances are so close, it's a little effort for beetles to move from one tree to the next. Trees are also so water stressed, they have limited pitch to ward off an attack. This lack of resistance allows beetle populations to explode. Temperatures in many areas are also allowing beetles to be active throughout more of the year. This situation resulted in 129 million trees dying in the Sierra Nevadas from 2010 to 2018 as a direct result of drought and beetles. And with the onset of the new drought in 2020, we're once again seeing beetle populations begin to rise in many Sierra Nevada regions. Collectively, this challenges California's climate goals. The state plans to be carbon neutral by 2045. Megafires challenge this goal by being met, as I mentioned, not only through loss of carbon sequestering trees and smoke, but also through damage to soil and elimination of seed in those hottest burned areas, making natural regeneration all but impossible and further impacting our ability for long-term carbon storage. The Forest Carbon Plan in May of 2018 was put out by the state following the beetle and drought die-off. Its goals, or I should say the state's goals within this plan, were to make California's forests more resilient and adaptive to climate change, as healthier forests wouldn't be overstocked forests, so they would be able to withstand drought and beetle attacks better, as well as remain a source of long-term carbon sinks and not sources of greenhouse gases and black carbon emissions from wildfire. Executive Order B5218 coincided with the Forest Carbon Plan, which was signed by then Governor Brown in May of 2018. It doubled the goal of land managed annually from 250 to 500,000 acres, which was going to be accomplished or will be accomplished through vegetation thinning, prescribed fires, and reforestation. This was matched by the U.S. Forest Service, who also pledged to manage 500,000 acres annually in the state. The executive order also streamlined permitting for landowner projects that improved forest health and reduced fire fuels on property. It supported innovative uses of forest products by the building industry and established a joint institute for wood products innovation. It requested $96 million to implement the Forest Carbon Plan, and it tasked key state agencies led by the Office of the State Fire Marshal with reviewing the approved ICC Tallwood Ad Hoc Code change proposals and to consider proposing their adoption into the building code's intervening code cycle, which you'll hear more about later today. The situation in our forests has continued to worsen. The domino effect was well underway before 2018. Both graphs here represent acres burned. The one on the left is at a statewide level, and the one on the right is just the Sierra Nevadas. Over 2.5 million acres burned in 2021, and over 4.3 million acres burned in 2020, which is about 4% of the state's total land area. The greatest impact on tree mortality in 2021 was from wildfires. It was the second year in a row of multiple record-setting fires and worsening statewide drought conditions. And many counties heavily impacted with large fires in 2021 were also impacted by large fires in 2020. These fires caused extensive mortality, and trees that survived are more susceptible now to insects, diseases, and especially drought. Aside from wildfire-caused tree mortality, substantial numbers of trees continue to die from higher temperatures, competition for water, and bark beetles. In 2021, 9.5 million trees over 1.3 million acres died. It was the third driest year on record. Statewide temperatures were 3.4 degrees above average. It was the second warmest year on record. In 2020, there were no U.S. Forest Service aerial flyover surveys quantifying the number of trees that died. But we do know it was the beginning of another exceptional drought period. Statewide temperatures were 2.6 degrees above average. It was the warmest August on record at 5.2 degrees above average, the warmest September on record at 5.5 degrees above average, and the sixth warmest year on record overall. In 2019, 15.1 million trees died across 2.2 million acres. Statewide temperatures were 1 degree above average. So as you can see here, the trend is hotter and drier. All this means that we need to increase the pace and scale of forest restoration now to help reduce wildfires, improve air quality, and increase water retention. The state is working to come at this from every possible angle, including innovative wood products such as mass timber. Scaling up forest restoration activities, the state will have increasing amounts of wood to process. We need to ensure we're using wood for its highest end use. We need to sequester as much carbon as possible through long-lived wood products. Mass timber can help us utilize salvaged wood, as long as we recover it within about 2 years during its usable period before it decays too much. Alternatively, it's going to decompose in the forest, losing all value, remaining a fire risk, and adding to our climate crisis. The mass timber industry can help improve rural economic development, make communities more safe from wildfires. It'll enable sequestering carbon and long-lived wood products, and it will reduce the need for more carbon-intense construction materials. Increasing innovative wood products such as mass timber will encourage capacity building, bring industry to the state, help support forest restoration, and further reduce California's carbon footprint with wood being sourced locally. The state recognizes the important role mass timber can play to help move the needle on forest restoration. AB 2518 ordered the Board of Forestry and Fire Protection to identify barriers to the in-state production of mass timber and other innovative wood products, workforce training, and job creation, and then to identify solutions to each that support the state's forest climate goals. The board contracted with the Sierra Institute for Community and Environment for the report. The report confirmed that California's interest in mass timber is helping to drive national interest. There's a growing demand in mass timber that will result in more manufacturers, some of which will locate in the state to be close to the market. It noted that mass timber sector requires a diverse array of businesses, from fabrication and hardware and connectors to design and construction. And it found that securing long-term supply guarantees will be important for industrial manufacturers to advance mass timber. It also found that inadequate sawmilling capacity in the state and lack of local markets for mill residues and other low-value wood fiber reduces the ability for forestry businesses to compete nationally and internationally, and this needs to be addressed. On a positive note, the report found that mass timber brings opportunities to reinvest in rural areas and the forestry sector, and that prefabricated and modular housing developments offer significant time savings, and mass timber is a pathway to close the gap on affordable housing needs in rural and urban communities. The report also found that workforce shortages are complex and should be addressed by considering job quality, livable wages, mobility within the sector, and general infrastructure development. There are examples of policy levers around the world that the report points to, which the state should look to for insight. To help raise awareness of mass timber as a quality building material that's aesthetically pleasing and can help improve sustainable forest management, rural economic development, and housing challenges, the state held a mass timber competition. Winners were announced in March of 2020. By showcasing opportunity, the state was trying to stimulate the demand for mass timber and generate investor interest in in-state production to help reduce the cost of mass timber to make it more cost-effective building material, leading to increased affordable housing. The awards are being used to fund activities such as cost studies, permitting fees, and information exchange sessions with code officials. All projects are still in the works, with some greatly delayed as a result of COVID. Winners include the California College of the Arts in San Francisco, who received $200,000 for a 107,000 square foot hybrid 4-story mass timber demonstration project as part of a campus expansion. Skid Row Housing Trust in LA, who received $200,000 for a 77,190 square foot 14-story building that will have 150 studio apartments and will serve disadvantaged residents who were formerly homeless. The Orange County Sanitation District received $40,000 for a 109,000 square foot new district headquarters hybrid building with a public lobby and lighting showcasing the wood interior at night. And Sunnydale Development Company received $40,000 for a community center which will house youth and family programs and recreational amenities in a distressed public housing site. Honorable mentions did not receive compensation, but did receive acknowledgement for their excellent plans. They include a Microsoft 2-story mass timber project that will have a living roof as part of the renovation and expansion of their Silicon Valley campus, and Tahoe Regional Arts Foundation that will have a free-form mass timber building that will serve as a central arts hub. As of December 2021, there are 199 mass timber projects in California that either are completed or are underway, more than any other state in the country. Washington is next at 126 projects, and Oregon is in third at 94 projects, with Texas close behind Oregon. Really, this slide is just to highlight the demand and interest in the state are clearly here for mass timber. The Joint Institute for Wood Products Innovation is another indicator the state is committed to increasing the use of innovative wood products. We first convened in 2019. We have 2 co-chairs, the chair of the California Board of Forestry and Fire Protection, and the California Natural Resource Agency Deputy Secretary for Forest and Wildland Resilience. We have 2 academic members and 11 council members with various areas of expertise, including forestry, industry, tribal interests, and finance. We're dedicated to providing California forest product information, research, and analysis to increase economic drivers for healthy forests. Our areas of focus include long-term ecological and economic sustainability, education and outreach, increased forest resilience, long-term carbon storage, local economies, and industry retention and development in California. Our first report was a literature review and research gap analysis of innovative wood products, which we released in 2020 and hired UC Berkeley to produce. Findings included identifying mass timber as a current promising market-ready innovative wood product. As a result, we funded research with the Tallwood Design Institute to look at cross-laminated timber layup tests using white fir species. We tested 2 different product layups using lumber grades 2 and 3 or better, with the intent of informing industry looking to come to California. Another contract we have pending with the Tallwood Design Institute is going to look at mixed species CLT layup tests using white fir species in the panel mix. Work should begin on this in July and be finished in October of 2023. Other projects the Joint Institute has funded include a UC Berkeley project that was recently completed on opportunities for low carbon and carbon negative fuels from non-merchantable forest biomass in California. It assessed the attitudes of low carbon fuel producers towards use of forest biomass and identified perceived benefits and barriers to adopting forest biomass, as well as offered solutions to the barriers. Other projects underway include Oregon State University's cellulose nanocrystals as a value-based additive for low carbon footprint concrete with limestone, which is utilizing cellulose nanocrystals from sustainably sourced wood fiber as an additive to aid in reducing concrete's carbon footprint. We also have Claire Inc.'s forest biomass pile data collection project underway, which is quantifying the number of forest biomass piles in the state that accumulated from 2018 to 2021. It'll look at areas, it includes the areas treated to create a given pile. The study will look at this. Composition, volume, and locations of the piles, and plan versus actual fate of each pile, as well as provide an inventory of forest biomass pile material potentially available for wood and biomass utilization. We also have a pending contract with Oregon State University that complements our other cellulose nanocrystal work with them. It'll assess the impact of cellulose nanocrystals on the service life of reinforced concrete, with an emphasis on corrosion of steel. Work should begin this July and is anticipated to be completed in early 2024. There is lots of good effort underway, but it's important to note that the number of sawmills has greatly decreased over the years. We have a lot of wood to process, and current mills are running at capacity or near capacity. There's a shortfall in California's ability to handle all the wood currently available, not including the wood that will be added to the load with our increasing pace and scale of forest restoration, and not including future megafire-related salvaged wood. For context, the state processes about 1 billion board feet of wood annually, and according to CalForests, the Dixie Fire alone burned about 1.6 billion board feet just on private land. Our current state capacity includes 22 to 24 sawmills. Each, depending upon their size, consumes about half to 200 million board feet annually. We have 2 green veneer plants, 1 export chipping facility, 1 whole log shavings mill, 1 utility pole manufacturer, 1 particle board plant that also processes whole logs, 13 biomass power plants that use primarily forest biomass, and at least 2 small industrial mills that should be coming on board in the next 18 to 24 months. Recognizing the need to implement a comprehensive statewide plan to address issues such as a lack of wood processing capacity and other forest health related issues, the state developed the Wildfire and Forest Resilience Action Plan that was released in 2021. It includes areas of focus, one of which is wood utilization, and it advances California's sustainable forest management goals. It lists the action items that need to be met and will get us to where we need to go for each topic. Wood utilization items include helping to attract and support private sector investments for an expanded wood products market. The Climate Catalyst Fund, based at iBank and the Governor's Office of Business and Economic Development, is one of the programs in the action plan. Its goals are to engage investment opportunities, provide technical assistance across all 58 counties, and it emphasizes inclusive prosperity in the climate transition. It has $74 million available, of which $47 million is available in loans for forestry projects, such as advanced energy products, existing and emerging construction materials, and supporting infrastructure and industries needed to make such products viable. The intent of the loans is to help stand up a more robust wood product sector in the state, to help reduce wildfire risks, promote forest and watershed health, and contribute to more climate resilient communities and economies. The fund makes public dollars available to help bridge financing gaps currently preventing technologies from scaling into the marketplace. And when recipients pay the loans back, those dollars return to the fund for other projects that need gap financing. The Governor's Office of Planning and Research Woody Feedstock Aggregation Pilot Project is another program supporting wood utilization in the action plan. As you recall, one of the barriers identified to entry into the wood utilization market is assurance of a long-term feedstock contract. Another is how to transport heavy material into remote and rugged areas. To address these barriers and others, 5 pilot projects have been established, and they're intended to help inform future regional projects as well. The 5 projects are the Central Sierra Project, the Marin Biomass Project, the North Coast Resource Partnership, the Northeast California Project, and the Tahoe Central Sierra Initiative. For the region, each project will develop and implement plans to improve woody feedstock supply chains, assess market opportunities for potential biomass and wood utilization businesses, work with public and private landowners conducting sustainable forest restoration activities, employ a governance structure, such as a joint powers of authority, and operate as feedstock broker, serving as a link between feedstock harvesters and biomass or wood utilization industries, procuring biomass and offering long-term feedstock contracts. Business and workforce development is another piece of the action plan. CAL FIRE currently has up to $24 million for wood products projects that support forest sector workforce and business development to support healthy, resilient forests, as well as people and the ecosystems that rely on those forests. Eligible business development projects include facilities, operations, and professional services that support the restoration of healthy, resilient forests and offer improvements to the wood products industry. Eligible workforce development projects include universities, colleges, government and community organizations, and businesses that aim to increase workforce capacity in the fields of logging, fuels treatment, transportation, manufacturing, and other support services that bolster a resilient forest sector workforce. Research and development projects related to both business and workforce development are also being considered. Projects receiving grant funding must demonstrate reduction of greenhouse gas emissions, economic strengthening, and improved public health. The goal of the granting program is to create incentives for industries to invest in clean technologies, develop wood products processing innovations, and support development of a strong forest sector workforce. So I end where I began. California is coming at the mass timber innovative wood products issue from all angles. The state sees mass timber as part of the solution to our forest health, climate, and housing issues, and has put in place many resources to support entities already working in this space or looking to establish a business that supports sustainable forestry and the mass timber industry. Thank you for your time.
All right, thank you, Katie. So we have another presentation before a short break, and then we will have some live presentations in the panel after that. So our next presentation is by Raymond Obrockie. Ray is the Manager of Fire Services Relations for the American Wood Council, which is one of WoodWorks' partners. Before that, he was the Chief Building Official for the City of Rockville, Maryland. He retired as the Assistant Fire Chief of Baltimore City Fire Department in 2013. He was appointed Fire Marshal for Baltimore City in 2008. He was also served on the NFPA Urban Fire Safety Task Force and has presented at the National Fire Academy and various venues around the country. He is currently a sitting member of NFPA 1 technical committees, the International Fire Code Committee, NFPA 101 committees, and the NFPA 241 committee. Obrockie is a graduate of the University of Baltimore School of Law and a licensed attorney as well. So thank you, Ray, and it's also a recorded presentation.
Hello, I'm Ray Obrockie. I'm the Manager of Fire Service Relations for the American Wood Council, and I'm just going to do an overview of the fire testing that has occurred regarding cross-laminated timber. This is one of our lawyer slides that I'm supposed to give. But anyway, we're going to discuss the history of cross-laminated timber. We're going to learn about the Tallwood Building Ad Hoc Committee because the testing originated out of the fire working group of that committee. We're going to review the ATF fire test, and then we're going to outline the most recent CLT fire testing at the Research Institute of Sweden. So mass timber as a separate building system was really born because of one new product, cross-laminated timber, or CLT. CLT represents a sea change in wood construction because of the new structural and fire resistance characteristics it represents for wood construction. Never before have we contemplated solid wood floors and wall sections used in a similar manner as concrete walls and floors. This is very much like precast concrete construction. It's panelized construction that is fabricated off-site, brought on-site, and assembled. CLT is typically dimensional lumber, 2x lumber, laminated in crosswise fashion, layer upon layer to make a solid wood floor, wall, or roof panel up to 20 inches thick and 60 feet long. It's been so far, it's usually 6 to 9 laminations, 6 to 9 inches thick. It's always odd number of laminations because it's built out symmetrically from a center panel. So cross-laminated timber is new to this country, but not new. It's been in Europe for years, and this is just a timeline of the history of it. The first patent in 1985, the first projects in 1993, but it really took off in the 2000s when the green building movement took place. So building officials asked the International Code Council to form a committee to explore the science of tall wood buildings. These buildings were being, these buildings of this type were being submitted under the alternative methods and materials process that's allowed in Chapter 1 of the IBC, International Building Code. So building officials wanted guidance on what should be approved, what shouldn't be approved. So the Tallwood Building Ad Hoc Committee was formed to explore the science of tall wood buildings, investigate the feasibility, and take action on any possible code recommendations. So the TWB had performance objectives. They identified a couple. One is there could be no collapse under a reasonable scenario of complete burnout in the absence of automatic sprinklers, no unusual levels of radiant heat energy exposure from the tall wood building to neighboring buildings, and then no unusual response to a typical radiant energy fire from an adjacent building to the tall wood building. Also, no unusual fire department accessibility issues. Sometimes that occurs during construction. The egress systems had to protect occupants during escape, plus a factor of safety. And last but not least, the suppression systems had to be highly reliable. So here's a picture of a CLT panel being lowered into place on the test structure that was constructed for a series of fire tests at the ATF Research Laboratory in Maryland. I included this photo to convey the scale of the mass timber. This single CLT panel is nearly 40 feet long, 8 feet wide, and 7 inches thick. It weighs about 3 tons. And I say the word weighs in the present tense because after the fire test series was over, the CLT was salvaged and repurposed for construction of residential buildings by architecture students at Yale University. So as you can see, CLT can be used in a horizontal application as like a floor, ceiling, or a vertical application as a wall. So early on, the Tallwood Building Ad Hoc Committee recognized it would need fire testing to validate its proposals. So the fire work group developed test scenarios, fire test scenarios, including the physical layout of the test structure, the configuration, and the fuel load. So the test structure represented a multi-story condominium in which each unit had interior dimensions of 30 by 30. So you had modern furnishings, not legacy furnishings that modern furnishings being a lot of polystyrene, foam, and plastics instead of the traditional natural fabrics and cotton batting and that kind of thing. The fuel load was based on a North American study of fuel loading for residential use groups. So what they did was they took the mean average of that study, added one standard deviation for those people who took statistics in college, and they came up with 570 megajoules per meter squared. And that was the fuel load. The express purpose of the test series was to evaluate occupant egress tenability and firefighter attack tenability, also to assess system responses to fire, and most importantly, guide code development. As I said before, this was conducted at the ATF laboratories and supervised by the U.S. Forest Products Lab staff. So this is just a typical apartment/condo layout selected by the fire working group for the 5 tests. The corridor and the stairwell were added when the full Tallwood Building Ad Hoc Committee insisted that all the construction must be compliant with the current of the day International Building Code and all the proposed code changes. Thus, there was a 20-minute door on the apartment into the hallway, a 90-minute door on the stair tower. The corridor was fully instrumented to determine firefighter tenability and egress escape tenability. As I said before, the 570 megajoules per meter squared is essentially the equivalent to about 400 gallons of gasoline, energy wise, when you look at it. This is just a rough structure. The partition between you had a 30 by 30 interior space. It was cut in half into two 15 by 30 rooms. There was an unrated gypsum wall in between. It was metal studs and unrated half-inch gypsum wall board. So here are the all 5 of the fire tests. So test 1, which was the so-called baseline test, this had all mass timber surfaces protected with 2 layers of 5/8 inch type X gypsum wallboard. It's a fire rated gypsum wallboard. So none of the CLT was exposed. This also did not have sprinklers, and there was no intervention to suppress this fire. Test 2, 30% of the CLT ceiling area in the living room and the bedroom was exposed, which amounted to about 20% of the total ceiling area in the test compartment. Test 3, 2 opposing walls, one in each room, one in the bedroom, one in the living room, was exposed. And the thing about test 1, 2, and 3, they simulate the highly unlikely scenario that there's a fire, the sprinkler system doesn't work, it fails, and nobody comes to put the fire out. Test 4, which is to me the most real to life test, has all of the mass timber exposed and the sprinkler system activates normally. In test 5, all mass timber surfaces are also fully exposed, and the sprinkler system is delayed by 20 minutes in activation. What this does is it simulates a sprinkler failure and a fire department response, and then they charge the fire department connection when they arrive. So each unit had plumbing, mechanical, and electrical penetrations, but no utilities were connected. They also had through penetrations and that were fire stopped, just to talk about the or examine the efficacy of that requirement for mass timber. So in this picture, especially in the lower right-hand quadrant, notice the cribbing that was added. They actually had to add cribbing to get that fuel load up to 570 megajoules per meter squared. This is just a shot of the bedroom and the bathroom. So in test 1, this, like I said, the baseline test, once again, all mass timber surfaces are protected with 2 layers of 5/8 type X gypsum wallboard. So all of the fires were started in the same fashion. They were started with a propane torch that lit a gasoline-soaked rags off in a pan in a corner base cabinet of the kitchen. And I said these things were fully instrumented. There were 420 channels of data collected during each one of these fires. Also note down in the lower right-hand quadrant, you have the 20-minute door to the hallway, the 90-minute door to the stair tower. So the fire starts very quickly. As I said, that 570 megajoules per meter squared was the fire load. Now, the original test protocol called for glazing on the front of these openings, but the engineers at the ATF lab they wanted a high intensity fire. So they left the glazing out to create more ventilation. Now, you have the living room kitchen in flashover right now at around 13 minutes. Flashover for laboratory purposes was 600 degrees Celsius, 1 inch from the ceiling, which is about 1135 degrees Fahrenheit. So you're going to see that the door was left open between the kitchen and the bedroom. The bed is starting to off gas now, and this room will be fully involved within within 17, 18 minutes. You see a little bit of smoke in the hallway, none in the stair tower. That 20-minute door actually lasts a lot longer than 20 minutes. So now we have fire that's absolutely free burning. It's in full flashover condition. This fire actually got to 23 megawatts. And to put that in perspective, a really hot campfire is like, that you can stand next to for a couple of minutes, is like 300 to 500 kilowatts. So this is like 45 times the intensity of that. So you see a little bit of fire coming through that 20-minute door that's hanging in there for now 35 minutes. It's going to hang in a lot longer. It's not going to fail until almost an hour when it comes to staying in the door jamb. So this wasn't the first generation of CLT fire testing. There was actually testing at NIST. So you see the fire is well into the decay phase when the door fails. No smoke or flame even enters into the hallway. The hallway was very tenable the whole time for occupants to get out, firefighters to get in. The test is terminated at 3 hours, and you can see that it didn't leave the compartment of origin. These are just still photos. The fire ignites, flashes over around 12 and a half, 13 minutes. At the peak heat release rate, over 20 megawatts. So the fire was allowed to burn without intervention. So, and you can see in the bedroom and the kitchen, all of the contents were completely consumed by the fire. The ATF firefighters didn't clean out this compartment. Everything was completely consumed. That's how intense this fire was after about an hour and a half. Now, test 2 exposed 30% of the ceilings. They also used barrels over top of that exposed portion of the CLT. They wanted to see what a live load would do to the exposed CLT. And this test starts the same exact way. It's in the corner base cabinet of the kitchen. Like I said, 30% of the CLT ceiling area in the living room and bedroom was exposed. That amounted to 20% of the overall ceiling area. And if you noted in the last test, that the steel studs and the gypboard wall partitions that were in between the glulam beams and columns were completely consumed by the fire. It should be noted that no combustible materials are allowed in concealed space areas. So you can you can expose the ceiling, but you can't enclose it into a concealed space. That's part of the adopted codes. And actually, this has 30% of the ceiling exposed. I'm going to telegraph that the code now allows for 100% of the sealants exposed in the 2024 edition of the IBC that I'll talk about, and that came out of the RISE testing. In 2016, the first Tallwood building, known as Brock Commons Residential Hall, was started at the University of British Columbia in Vancouver, Canada. That's 18 stories, and that was the tallest structure in North America utilizing mass timber. There's currently a building almost complete in Milwaukee called the Ascent that's going to be 25 stories. It's 19 stories of CLT over top of a 6-story cast-in-place concrete podium parking garage. So right around 12-13 minutes in test 2, you see flashover in the living room kitchen. It starts to also spread into the bedroom. This test goes very much like the test 1. Like I said, they did run electrical and mechanical in these units. They didn't hook them up. They didn't see the need to. They also didn't have appliances in the kitchen because they wouldn't have contributed to the fire. They were unneeded expense, so they left those out. But everything else was real to life. The fuel package was all bought at IKEA, by the way. It was $5,000 worth of furniture for each test. So by the end of test 5, the ATF firefighters were pretty tired of putting together IKEA furniture. So you can see here we have fire in both compartments, flashover rather. That 20-minute door is still hanging in there, and you don't see any smoke intrusion into the stair tower, the 90-minute door. We're going to speed the test up just like we did the first one. The test is, the fire's in the decay phase, as you can see, and the door still is in place. The door will actually fail at about an hour again, and by that time the fire is so far into the decay phase that no smoke or fire even goes into the hallway. Also, once again, as you can see, the contents of that apartment are completely consumed by the fire. They were consumed for about an hour and a half. Door fails, and they terminate the test at 3 hours again. Once again, these are just still shots of test 2. Ignition, flashover in the bedroom all occur roughly around the same time. But notice the char formed on the exposed mass timber ceiling area, which was expected. This is a good picture. In this photo, you can see the post-fire condition of the CLT. They removed all of the gypsum wallboard, and you can see that char area, that rectangle to the right of the man on the ladder. That's where it was exposed. You see a little bit of smoke, scarring or surface charring at the corners of the glue lamb beams and columns, but it's really pretty clean wood after a fire of that intensity. This photo shows the sample cross-section, which was taken from the exposed CLT ceiling following test 2. This sample, the char had been actually scraped off in order to get a more clear measurement on the depth of char. And I don't think I told you, this was a 5-ply CLT Douglas fir large species CrossLaminated timber, and had 5 laminations. So if you count from the top down, you see 1 lamination, 2, 3, 4. So this fire burned for 3 hours and never even made it to the first bond line of the first lamination. So this is the test layout for test 3, which had 2 exposed walls, one in the bedroom, one in the living room. For the sake of time, I'm not going to show the video just because it pretty much goes the same way as the first 2. It burned for 3 hours. There was flashover in the bedroom, in the living room and in the bedroom right around the same time. The exposed walls charred, and the only thing that was notable in test 3 was that there was a mistake in the way they installed the 20-minute door. So it failed at 17 minutes, but still the fire did not spread into the hallway. Now, test 4, this one I say is probably the most real life example because it is fully sprinklered, and type 4A, B, and C construction has to be fully sprinklered. The sprinkler system activates normally, and the fire gets put out. And also they have glazing on test 4 and 5. So most people don't have a big 8-10 foot wide portal opening in the front of their apartment. So this one, to me, is the most realistic test. I never used to show it because it was the most anticlimactic test. I mean, the fire breaks out of that base cabinet and the sprinkler puts it out almost immediately. But my good friend Shane Ray at the National Fire Sprinkler Association told me to put it back in because it shows how great his sprinkler systems work. Now, these wall, the front wall has glass on it, like I said, and fire sprinklers, according to the National Fire Protection Association, operate effectively 93% of the time. So that's a pretty good percentage. So that's why tests 1, 2, and 3 were, like I said, highly unlikely that the sprinkler system would fail. And if it did, nobody responded. In this test, like I said, this is, I feel, the most accurate test on how, in a sprinkler building, with all things being equal. You see those tripods set up in some of the tests. Those were deluge valves. The ATF was worried in test 1, 2, and 3 that the fires got so high in intensity that it might damage their hood system, because in the ATF lab, they have a big hood over it. And they were worried about damaging it. It was an abort button. They never had to hit it, but they had it there. You see right at the 2-minute mark, the fire breaks out of the base cabinet and the sprinkler system extinguishes it immediately with just one sprinkler head activating. So these are just some photos. In test 4, all of the mass timber surfaces were fully exposed in the bedroom and the living room, and the automatic sprinklers were allowed to activate normally, which they did at about 2.5 minutes after ignition. The sum total of damage can be seen in the lower right-hand quarter of the picture. So you see the fire damage is really confined to the point of origin. Now, test 5, this is where they delay the sprinkler system by 20 minutes. Actually, in reality, it was delayed by 23 minutes. So this was to simulate a sprinkler failure and a fire department response in charging the fire department connection. But what it really was trying to test was, if the fire got a head start on the sprinkler system, could the sprinkler system rather overcome the head start the fire got. Now, in tests 4 and 5, I also forgot to mention, they left all the doors open. The doors to the hallway, the door to both rooms were left open. So as you can see, the fire is starting. I think it reaches almost flashover it does reach flashover in the living room, almost into the bedroom before the sprinkler activates. So this one was to try to see what the sprinkler system would do if the fire got a head start. Also, I said that all of the CLT was exposed, which it was where it was allowed to be exposed by the code. So you see the fire set up the sprinkler system at 23 minutes. The sprinkler system puts it out, about 7 heads activated, and effectively extinguishes the fire. But you can't expose all CLT because you can't have exposed wood in bathrooms and kitchens. So you have to cover that, but it has nothing to do with fire safety. It has to do more with hygienics. So as you can see, all the mass timber surfaces were exposed. The sprinklers extinguished the fire successfully. It was a pretty straightforward test. Now, this is just a rubric or a summary table of all 5 of the ATF fire tests. The flash over the living room and the bedroom. The flash over the living room was fairly consistent at around 12 to 13 minutes. Flash over in the bedroom was even more consistent at around 17 minutes. So what this really says is that building construction has nothing to do with flashover times. Flashover is really driven by contents, and because the contents of every test was the same and consistent, the flashover times were the same and consistent. So it didn't matter how much CLT was exposed. It just, the times were consistent because the contents were consistent. And you can see flames in the hallway, compartment door failure, and then in test 3, you can see there was a door frame installation error. So if you want to read the full report on this, these are your websites you can go to. You can see the test videos at the American Wood Council website, www.awc.org/tallmasttimber. Now, I want to talk about the research at RISE. The research recently completed at RISE involved compartment fire tests that were similar in many ways to the tests performed at ATF in 2018, except for 2 very important differences. First, unlike the ATF fire tests performed in 2018, the RISE tests were performed using PRG 32018 compliant CLT. As you can tell by now, our discussion on prior slides is a key point that the newer generation of CLT made it possible to achieve the second major difference from the ATF fire test. See, to go back, the original fire testing that occurred at NIST that I talked about, the CLT didn't perform that well. It delaminated it. It came apart and created fire regrowth in a second flashover. So they went back and they said, listen, we need better adhesives to adhese the CLT together, something that is heat resistant. And they came up with the ANSI PRG 320 standard, which I'm going to talk about later. But at the time of the ATF fire test, there wasn't any PRG 320 compliant CLT available. So they changed the configuration of the CLT, and that's how they performed the fire test. So they wanted to figure out exactly how much mass timber could be exposed safely. So in developing the mass timber provisions for the 2021 I codes, the committee wrote provisions requiring, like I said, the CLT to be compliant with PRG 320. The standard includes mandatory adhesive qualifications that preclude the use of adhesives that exhibit heat delamination leading to fire regrowth. So like I said, it wasn't available at the time. During the RISE testing, it was available. So as you can probably guess, then the primary objective of the research was to determine whether the increased areas of exposed mass timber are justifiable using CLT that is compliant with PRG 320. There are secondary objectives too, but this is the primary one, and I'll talk about those. So as we'll see in the next portion of the presentation, the RISE research achieved this objective. They wanted a severe but representative fire. That was their criteria. And they wanted to assess the performance criteria, which PRG 320 says the fire has to decay continuously 4 hours until 4 hours after ignition. But they had secondary objectives. One was design and test intersections between exposed mass timber members. They want to record facade exposures, allowing for comparisons with standard facade testing methods. Every country tests facades a little differently. In this country, it's NFPA 285 is the test standards that's used. They also wanted to look at their predictive modeling. The fires at the ATF lab, they were fire modeled a month before the actual test, and it was pretty good how the modeling lined up with the actual test results, but they wanted to see if they could improve it. And then there's a case study for restoring exposed CLT members after a fire. I always get a lot of questions on what happens if it gets damaged. How do you repair it? So in all of the tests, the ceilings were exposed, and the beam under the ceiling was exposed. The gypsum wall board is represented in red on this diagram, by the way. Test 1, only the ceiling was exposed and the beam under the ceiling. Test 2, the walls were exposed. Test 3 had intersecting walls and ceilings exposed. Test 4 had a larger opening factor. So it had a larger opening in it that represented well, I'll talk about opening factor later, but it was a commercial sort of opening factor. Test 5 had the same configurations as Test 3 with one big difference. The front wall was protected, resulting in no intersecting walls. So the opening factor in Test 1, 2, 3, and 5 was the average for residential structures according to a study of 700 residential structures in London, actually. Test 4 had an opening factor consistent with the average for business occupancies. So the configurations were based on a combination of things. So what they did was they did test 1, and then they got together and they looked at the performance of that test. They looked at modeling predictions, and then in the opinion of the steering group, they created the configuration of the gypsum wall board for test 2. And then after test 2, they did the same thing. So they did one test before they did the other test, and they changed the configuration. So the fuel was typical apartment furniture, supplemented with wood cribbing. Test 4 actually decayed the quickest and had the largest opening. Test 1, the fire decayed 22 minutes from flashover. Test 2, 3, and 5, about 6 to 8 minutes after test 1. Test 1, 2, 4, and 5 all decayed steadily until the 4-hour mark, just like the performance objective was states. Test 3, the fire did not decay and still had flaming in the lower left and right walls at the 3.5-hour mark. It had exposed intersecting walls not present in test 5. Even though it did not pass the performance criteria, it did perform significantly better than the CLT and those earlier NIST tests that I was talking about. Several measurements were made during the test, as would be expected, about 2,200 degrees Fahrenheit at its peak, down to 120 degrees Fahrenheit in 4 hours. That was a steep decline after 30 to 40 minutes. Test 4 decayed the quickest because it had the largest opening factor. Test 3 did not pass because the fire never fully decayed by the time the test was stopped. Just a couple graphs here showing the loss of mass and heat release rates for the 5 tests. And the 5 tests are represented by each a different color. This would be a diagram showing the depth of char. Imagine standing in the compartment looking up. The bottom of the walls would be the outside row of numbers on the diagram where the char, the depth of char was the highest. The ceiling showed the least depth of char, actually. This graph represents the char depth on the ceiling. Test 4 had the lowest depth of char due to the larger opening factor. I added the NDS char depth standard presented by the red line. The National Design Specification for Wood Construction char depth standard represented here is for 2 hours of fire resistance rating. Even test 3 is under the NDS standard for char depth on the ceiling, even though it didn't pass the test. The graph represents the char depth on the walls of test 5, or the 5 tests. As you can see here, test 3 exceeded the NDS char depth standard. For those who didn't know or don't know what the National Design Specifications for Wood Construction is, it's developed by the American Wood Council Wood Design Standards Committee, and it's been approved by ANSI as an American national standard. So there were 7 different methods there were 7 different connecting design methods. So with varying methods for sealing the connections, the goal of the seal is to prevent the flow of hot gases. The connections are protected within the wood. So all the airtight sealed mass timber intersections were effective to prevent fire spread. And one of the design intersections had locally no airtight seal and led to smoke and flaming through the intersection. So you can see that here. There was a geometrical imperfection in the where they met, where the CLT met the other CLT, that left a gap. And as you can see, you had early smoke spread through the compartment before flashover, and flame spread through. There was where there was no imperfection, there was no fire spread. It was learned that acoustical tape covers larger geometrical imperfections and can prevent smoke and flame damage. So you see that acoustical tape right in this photo, and you see it on the outside of the test compartment. So you have to allow for geometrical tolerances, so they have to be accounted for. The sealing material doesn't have to be resistant against elevated temperatures if it's positioned in a well-insulated location. So they also wanted to compare different facade testing methods with CLT. It used different test methods from different countries. The British BS 8414 test was the most representative of a real fire and real fire behavior. The Swedish test was the least representative, also compared the facade exposure test to NFPA 285 standard. So they also wanted to improve their predictive modeling. After the test, they analyzed the test results and updated the model. This is just a diagram that basically informs how the model works. The main model updates after comparing a priori modeling to test results, resulted in changes of radiant interaction after flames disappear, inclusion of char oxidation after flames disappear, and oxygen that reaches the char surface. Now, one of the more important aspects of the secondary objectives was case study for restoring exposed CLT members after a fire. Okay, and this is just a video that was put together. So after the tests were over with, they cut out a piece of the CLT ceiling. Now, they didn't restore it on site because of logistical issues, so they took it into a lab and put it at the same exact height, same position that it was in during the fire. So then they determined the depth of char. That was step one. Step two, they designed a new CLT layup. So they used gap filling adhesives with 60 millimeter replacement glue lam laid on its side with a temporary tensioning screws and a veneer layer finish. So that's what they came up with the design. So they plane everything out. They scrape all the char out. They sand it, they plane it, and obviously vacuum everything out, including the corners. Then after that, they screw glue glue lam on its side to take the place of what was planed out and what was charred away. So here you see that they're screw gluing and replacing the laminations. So once they screw glue it, what they do is they seal everything. They actually remove the screws because the screws are metal and they felt they would conduct heat into the interior of the CLT. So then they sand it after they remove the screws, and they put on a veneer finish layer. And that's the patch for the CLT. So here you see just a side view of the repaired or restored CLT member. And then they actually test it. So they tested the panel after repair. They found out the flexural stiffness and bending capacity was exactly the same. However, it did have reduced shear capacity, but it was sufficient for most applications. So basically, where you would have a relatively short span under a high shear load, this fix wouldn't be the best fix for it, but like I said, most applications it would be fine. So some of the conclusions of the fire testing is CLT is what makes mass timber buildings possible. CLT has been extensively fire tested. CLT performs very differently in fire conditions than lightweight wood construction. And in the IBC, it is associated more with type 1 construction than it is with type 3 or 5 construction. And it the fire resistance ratings for type 4A and 4B and 4C it mimic the fire resistance for type 1 and type 1A and 1B.
I have the honor of introducing our next speaker. We have Chief Greg Anderson. Greg has been the Chief of Code Development and Analysis for CAL FIRE, Office of the State Fire Marshal, since 2015, and has been with the state for over 27 years. Greg was promoted through the ranks from a field deputy to plan reviewer, and then as supervising deputy fire marshal responsible for the Fire and Life Safety Division in the Central Valley. Greg started on the education path with a major in physics, but holds a Master's of Arts in Leadership Sciences, or Leadership Studies, and a Bachelor of Science in Organizational Management, an Associate of Science in Business Administration, and an Associate of Science in Fire Technology. Greg is also a certified fire marshal by the State Board of Fire Service. Thank you, Greg.
Good morning. Well, it's nice coming up after everybody where a lot of the points have already been covered. So should go fairly quickly. I gave you some pictures of what a CLT is, but you've already seen lots of pictures and you have a really good example behind you. So it is not your standard light frame wood fires. And I know with the fire service, we're very conservative. When you think of wood construction, and we think of the fires, especially the construction sites where we had in LA, huge fires, yeah, we get nervous. So, same picture, I think they came from the American Wood Council, but it was a big deal to bring in a new type of construction. I mean, it's actually historic. We've had those tables forever. Yeah, we tweak them a little bit, but to actually add new columns, and it didn't come quickly. In the code development world, we've been talking about mass timber and CLT for 10 years at least. And it was proposed at the ICC, and we said, no, we need more testing. And the industry stepped up, and they provided the testing. And then ICC started, and they got their ad hoc committee working on this, and there was a lot of questions. And a few changes were done from those testing, such as the laminate. It was a long process that was truly vetted through. So we started with the new 3 columns, which are your new type of construction. Your type 4A, which is the most restrictive and allows up to the 18 stories. And you understand, CLT, just the wood itself, passes a 2-hour fire test. This is already a 2-hour fire assembly. And then we go with type 4B. This is where it's a hybrid, which is kind of different for the code. And we had a lot of discussions whether we should be doing this, but we did. Where we go, oh, you got to cover most of it, but we allow 40% of the walls open and 20% of the ceilings. And there are some ratios you can't do the 40 right to the ceiling. It's got to be separated out a little bit. And then of just type C, which is, hey, you can do the whole thing exposed wood. So here's some examples. We got type 4, excuse me, type 4A. Maximum height 270 feet. Maximum story of 18 stories now. We still have that in California, but you don't get height and area increase at the 18th story. But we added a lot of things. We always want sprinklers. If you're going to build a smaller CLT, hey, you can build a type 5A or B, you know. And then you can get into the exceptions. But for this, sprinklers. You will see, I noticed on the table before, that there was some numbers for non-sprinklered. We have to have those numbers. I found out the hard way because when you're doing frontage, you have to have the base numbers to do calculations. So the primary frame ends up being a 3-hour assembly at least, okay? And we got some more numbers. Another thing we put in there, if you go over 120 feet, stair tower has to be non-combustible. And this is firefighter safety because we're going up that high. How long is that really going to last? Do we have any other issues if it's spreading to our stair tower? And then concealed spaces. Yeah, we can have concealed spaces, but just like anything with NFPA 13, you have to provide protection per NFPA 13 because it is combustible inside. Then we got type 5B, max height of 180 feet. Maximum stories is 12 stories. Same thing with the double dipping. Yes, we want sprinklers. Our primary frame is still 2-hour construction and fire resistant. 80 minutes, we're going down to stair towers. It can be mass timber, okay? And concealed spaces is going to be the same for all of them. Type 4C. This is fully exposed building. So, hey, we give you 9 stories, up to 85 feet. Sprinkler, yes, still 2-hour assembly walls for the frame. And again, of course, the stair tower can be mass timber. So, 2 layers on a 2-hour assembly already. So we're getting at least our 3 hours. So, and the exterior has to be non-combustible. Because we've looked at a lot of the fires we've had in high rises going up the side of the building. Numerous ones in Dubai that we've been watching and issues. So out there, over 120 feet, we need our 2 water supplies. And a big one that came in, we need special inspection. And a lot of this has to come with a learning curve. Mass timber CLT construction is new. There's a learning curve here for everybody, from the industry to the inspectors. I remember the first time I was out in the field and I found a flexible sprinkler head. You have no idea what it is. You know, you got to get the specs, you're looking at it. Oh, it's going to be the same over here. When we're looking at how do I do a joint, and joints are always the weakest point. So, special inspection, and we'll have a lot of questions. So, how did I get involved? Besides being part of the ICC and listening to all the arguments at the national level, and then participated in the ICC ad hoc. So it was approved. We brought it into the ICC. Great. Oh, wait. I've now had an executive order from the governor's office saying, can we bring this in early? And I think on my next slide, oh yeah, the assembly also stepped up. And they put out a concurrent resolution saying, oh, we should really look at this. That started the State Fire Marshal's work group. And we got a lot of people together for this. We got the wood industry, HCD, of course, because a lot of this will have to do with housing. We got DSA, very critical structural engineers. They're the ones that look at the structural requirements. We brought in, of course, the Building Standards Commission, the Building Industry Association, Board of Forestry, of course. Oshpod, which wasn't a big player because there's his hospitals, and I don't think is their market because of the health issues. Exposed wood isn't a good thing. We brought Cal Chiefs in, government operations, that's from the governor's office, Calbo, of course, Society of Fire Protection Engineers, ICC. We had the iron and steel people there, concrete. It was well over 150 people on our work groups with interested parties. We've been doing our meetings virtual and live for a long time, well before the pandemic. So fortunately, all those people weren't in person. And we vetted these things out. We looked at the way they did the test. There were arguments about whether the fire tests were appropriate for CLT. The tests we've been doing for over 80 years. Yeah, at the end, we're going, yeah, we're good with this. It's a 2-hour test. We were looking at the safety requirements. Is this appropriate? And at the end, everything that we did brought it to the highest level of safety that we could. The ICI Ad Hoc Committee, they actually looked at the comparison to type 1 and said, well, that's unlimited. We're not comfortable with that because this is combustible. Then they went down a notch and said, okay, that gives us 24 stories. And we went, that's a little too much. They cut it in half and go, well, that's a little too low. And they came with the 2/3. That's how they came up with the 18 stories. That's how the numbers worked, okay? So that number of being conservative to make it a viable option. So going through all the codes, we looked at the type of construction, how we matched it. Here we go. Type 1.5B, same thing, 2/3. And then I go quickly through this. Now, what's really nice on the fire test, I don't have to talk too much about it because we already had a presentation on it. I've watched all the fire testing. Yeah, it's a lot of time. I have become very comfortable with these. Do I have concerns? Absolutely. That's my job. I look at where the problems are. I have questions on how you repair that. I actually enjoyed the testing that they did of how you repair panels. I see it's going to be difficult. Hopefully that won't come up too often, especially if the fire sprinklers work. We're really not looking at that issue. All the testing was, if this system fails and this happens, we always test for worst case scenario. At the end, we're going, wow, it came out pretty good. Because believe me, we were looking for anything wrong we could with it. That's our job. So a lot of discussions, especially on the structural issues. Now, I am not a structural engineer, but we did have the structural engineers come in there. We had the state DSA, their structural engineers. We talked about seismic. And at the end, code didn't give away anything. They have to meet the current standards. So nothing has changed. It is the code. So now there's another one of the concerns that come up. A lot of those systems right now are proprietary. So doesn't mean it's wrong. It just means that's more work and more documentations. So I believe that will be changing in the future, but it is one of those issues we'll be dealing with moving forward, especially another good validation for having a special inspector. As we move into the exciting new world of tall wood buildings. And you can see from the governor's office and the legislation, this meets the agenda. We are looking at this. At the State Fire Marshal, our role is, can we do this safely? And I believe this is a very conservative viewpoint to do this. I will say at the last ICC code hearing, I just got back from Rochester. Was it there? No, it was a Cycle A. They all blur together. There were proposals to raise the height and increase the areas. Those did not pass. We are not comfortable with that. We still want to see these buildings built because most of us in the fire service have not seen one of these built in our jurisdiction. There may be some exceptions, and a lot of them, I think some of the examples they brought up that through the program with the governor's office were smaller buildings. Well, yeah, you can build with CLT and it can be a smaller building. You don't even have to call it type 4, A, B, or C. You can, if it's small enough, it's type 5. So, but it's a new product. We're all getting used to it. And I like to look at the education portion of it because that's really where a lot of this comes from. And we lean maybe heavily on our national partners. ICC is stepping up. There's a lot more training that's going out there, and it is expanding as we work on this. I know that State Fire Training, our office, was looking at some of the training programs, but most of it on the products, that's not where they focus on it. We also have our building material listing program that does some, which we will list things that's not mandated, but we have our engineers who look at systems to see if they meet the testing standards. So as we went through all, we went over the height and area numerous times. We beat everything down, talked about it forever. At the end, we did do the one thing in California, which we talked about. We didn't have the double dipping. And that is the only change from the national codes. Everything else is the same. Exterior coverings, the type 4A, non-combustible. Stairways, non-combustible over 120 feet. Sprinkler requirements, yes. Concealed spaces, already covered in NFPA 13. It's combustible space. If it's there, you have to sprinkler it unless you meet one of the numerous exceptions based on the size. Assemblies, we looked at a lot of different assemblies. We had examples brought in. We considered them. We looked at the fire testing, whether there was a 2-hour, we're looking at the joints. And then, of course, we've already been talking about the training. We realize that everybody is going to probably need more training. One of the key things that I think will assist all of the AHJs is that special inspector. That is a big deal when you're having a new product, especially an entire new system, in this case, a type of construction. To have that special inspector to lean on is a big deal. And then repairs, we were already talking about. So during the presentations, we did have presentations from the structural engineers, went through the whole thing numerous times. Seismic is, of course, a huge concern in California. We saw the shake tests that were done. They're fascinating, but at the end, we didn't give anything away. If there's any doubts, it has to be shown that it can pass the test. So, that being said, we brought it in the 2019 intervening code cycle. And that was a big lift for all the state agencies. For those who still have the hard book copies of the codes, that supplemental was really large with all the blue pages. And this is the reason why, one of the major reasons why. And we adopted it through the State Fire Marshal, HCD, Building Standards Commission. We all did a joint adoption of this. So let's see, the only changes was on the height and areas. And of course, I get to do the work again, or already did for the next cycle for our 22 codes. We had to repeal all these sections and adopt the model code to change it from italicized font to regular font. No change, looks the same, except for the font is different because there's no longer a California amendment, it's now model code. So you'll see a lot of pages and a lot of work that was done to coordinating with all the state agencies to get this in early, and it is in effect now. So it's already here. We realized it probably wasn't going to be utilized very quickly, but this met the goals of it's here, you can do it, and it's a huge sign to the industry that it's here. They can start preparing it, and there's a lot of things when we already talked about forest management and the number of supply chains that have to happen to make this work. It's a big deal. And to have that 18 extra months and they know that it's coming, it's here in California, it gives them more time to get that done and speeds up the time frames. So this is the way it came in. We brought it in July 1, 2021. And of course, when we started this, we didn't have a pandemic. None of us expected that, and I don't know if that affected the construction or not. I know that as we look at the priorities, well, actually in the last 2 years, the priority of the legislation has been COVID, wildland fires, and affordable housing. And this is one of the things that may assist with the affordable housing. You see some of the projects that were approved, and especially with the the structural spans in apartment buildings, this is what it's really suited for. Yes, you can do the larger spans, but it definitely takes more engineering. A lot of times you'll end up going back to steel. Speaking from somebody who's not a structural engineer, but I sat in way too many meetings. So, are there other issues? I mean, we've already talked about the proposals and what may be coming next with the special inspection, seismic and structural concerns, fire testing, construction fight, other issues. We're always looking for other issues. And I love to hear issues that happen. We did have one in Oregon where we had a panel delam that came down. One thing. It was a defect in manufacturing. Does that derail the whole thing? No. How many other projects have you had something that failed because it wasn't built correctly? So that isn't a red flag to me, but it's something else to look at. So, and given some time, because we at the fire service being conservative, we want data. We want to know how things are working. Well, when it's a new type of construction, we don't have data. The only data we can get is fire testing. And as I say, the industry really did step up. They did the fire testing, numerous ones at their expense, and we reviewed them. And at the end, they convinced us. We passed it. So it says 4 meetings. I swear it was more. It felt like a lot more. They were long meetings. So we finished up in 2020. It was final approved, published, and effective. And so you'll see it, of course, in the next 22 codes. And that's all I had, because everything else has already been covered by the other groups. But I am open for questions. It's a topic I love talking about. Come on, you're exciting. Yeah, here we go. Well, and as a lot of times goes with the building official. Oh, thank you. The question is special inspection. What are we looking for special inspections? Most of the ones I'm concerned are the joint, where your wall joints come together. Now, I'm speaking from the fire side. Your structural engineers and your building officials will probably answer that slightly different. But I'm always looking at where my wall assembly comes to the floor assemblies. That's going to be a weak point. And the way they are connected. From a structural engineer, you're looking how things are connected to make sure that it's done correctly. Yeah. The question was, how do we determine who's qualified as a third party? ICC and some other organizations do have training programs. So you're looking that they have some certification that's being worked on right now. It's the same as you would with any other special inspector. I'm pretty sure they were working on it. I'm not sure if it's done. So I don't want to give the wrong information on that. Question in the back. The question was, do we have listings for the different, and it's going to be for the rating. A lot of them would be the E84, so it's a fire test. And yes, there are some that have been tested and approved. So yes, because those are things we're looking for. Absolutely, to meet those qualifications for a fire rating, was it tested and was it approved? Any other questions on the safety, the construction? I like your question you had early about firefighter effect on long-term with cancer, which is a huge issue we're having with the fire service right now. I don't know any of the long-term studies because it hasn't been around long enough to have good studies. And I will follow up on what I said before. I still believe wood isn't going to be the biggest problem. The laminate might be, but it's nothing compared to what we have in the building with all the plastics and material. And as you know from the fire service, it's a huge issue that we're dealing with right now and losing our ranks. Well, anything when we look at the water, and NFPA has done studies, not specifically on mass timber. The damage is a fraction of what the damage would be from a fire. Because a normal sprinkler head, residential is 7 GPM, probably commercial, you're kicking up to 10, 15, maybe a little bit more, a gallon. Compared to what that fire will do to the entire area and spread and destroy all the panels versus some water damage. And especially if it's mopped up quickly on the floor, it's a lot better. And you'll see even on the test that done by ATF, one sprinkler head put it out. Now it's cleaning up that room. That's a lot easier than the destruction of the 2 rooms that it showed on that same test. It's a fraction of the cost. And it's a huge thing on sprinklers because everybody thinks, oh, the water damage. No, if you break a pipe, yeah, but you break a pipe in the bathroom, you have the same problem, isn't it? It's just a water pipe. We could talk about sprinklers and how they actually work, not how the movie shows them too, but any other questions? Yeah. I don't believe it. I saw the shake table. It wasn't a extensive studies. They were showing it because at the end, oh, the question was on the seismic and the testing that they have done. At the end, there's no change in the regulations. Like anything else, they have to show that it's listed for the seismic. It's not a new requirement. They have to show that it meets what's already in the code for the seismic zone. So it's up to each product and how they're doing it to show that it works. Certainly. Any other questions? Oh, actually, I was pretty close on my time. Well, thank you.
Thank you, Greg. That was awesome. So our next speaker we have joining us, Bevan Jones, Holmes. As principal and CEO of Holmes US, Bevan is driving an approvals path forward for modern wood construction. His involvement with ICC Ad Hoc Committee on Tallwood Buildings provides him with valuable insights into the regulatory process for adoption of mass timber, specifically CLT, under various model code adopted throughout the US. Bevan is a firm believer that establishing a sound compliance strategy at the onset of a project is fundamental to progression, particularly when adopting new construction technologies. Working with owners and project teams, Bevan crafts fire engineering designs which keep the architectural intent while finding solutions to difficult code requirements, including egress, fire separation. He enjoys the challenge of applying first principle design holistically to achieve a practical and efficient solution. Are you running it from up there? Thank you.
Thanks, Chelsea. Appreciate that. I've got to cut that bio down. It's a little extensive. Firstly, I want to actually thank Greg and commend his office and other agencies involved in California's review of the Tallwood Building Provisions and early adoption of those into the interim 2019 code cycle. So it's great work there to sort of bring that into California, and it's a very progressive movement, and we hope to see similar sort of action on board as we see the changes to the IBC 2024 as well that are now working their way through the process. So thank you there. And again, secondly, I know that there's a lot of people from agencies here and taking a lot of time out of your day to be here, so I really appreciate that. I know you're all very busy people. So on that, can I get a raise of hands on who's had a mass timber project come through or is working on a mass timber project now through those jurisdictions? Great, okay, it's good to see that. And I guess secondly on that aspect is, it's a big point here is that wood burns. We're not going to try and sort of put that under the carpet. It's an important aspect of understanding that wood burns and really, as Greg identified, this sort of difference between identifying how we work with the new engineered products and large mass timber elements versus stick frame construction, but also realizing the amount of research and that has been undertaken to sort of get us to the point we have here now with regards to the code adoption provisions, as well as what's forthcoming in subsequent code cycles as well. Also understanding the gaps in the industry, realizing that we don't have 80 or 100 years like the steel or concrete industry have. And there's still a lot of things that are in play to address some of the concerns that you as a jurisdiction may have. And so that's really where my role comes into here, to try and understand kind of how we can take the research and code adoption process that Greg and others have outlined today, and how do you get that into a project and start to work through some of these concerns that jurisdictions have. And part of that is sort of getting into some of the major questions that really start to drive a lot of the factors that clients and the industry is pressing towards, because the advocacy and the adoption and the progression of mass timber is rapidly accelerating, really to really pick up on the drive to hit these 2030 and 2050 targets for sustainable building design. Construction industry hasn't really changed a lot in the last 100 years. It really needs to do a lot of work now to get to where we need to be. And so, there's big drivers there, but there's other aspects that really come into play, like, it's very difficult to find a green field construction site anymore. So really looking at the modular kit of parts process of construction occurring off-site and being bought, and reducing labor force and time frame to put these buildings together. Anyway, I'm getting a little bit off topic, but I'll get into the fire stuff. Perfect. Just checking on progression of the slides here. Cool. All right. So just quickly on my agenda, really just applying mass timber into an actual project. Talking about some of the goals that projects will usually have, and sort of how we talk about the fire performance in relation to those project goals. We just start to see some conflicts and how we start to bridge those conflicts. Really just a quick overview of fire resistant design. I may skip through that pretty quickly because I think we've covered through a lot of those aspects already. And within the value-added design process, we start to look at the adoption of some of these, the testing that's been undertaken, fire engineering principles, and then how we look at and employ that from a approvals perspective of working through with jurisdictions, and then implementation into a design and project. That's already done. I'll skip that. Really now looking at applying mass timber. So here's a quick, easy graphic that I try to use with clients to really convey the opportunity that mass timber has across the board, looking really at the existing construction types that we have had in the previous code with 3, 5, and 4 heavy timber. We can use mass timber within those construction topologies now, and then it actually provides quite a big advantage when we're looking at a number of mass timber projects, particularly residential and low-rise commercial, where we can utilize that mass timber in combination with hybrid construction techniques to really create a rapid and robust building product. And then we get into the new construction types, type 4C, B, and A, where we start to be able to increase the floor plate size and even height, such as the 4B and 4A above that 85-foot criteria, which has really been a limit for wood construction here in California. The hot topic really is and has been brought about a number of conversations today, is really about how much mass timber we can expose. Type 4C, which is on the bottom there, really is we can go up to 85 feet. We can have a slightly larger floor plate, like 1.25 times what Type 4 heavy timber allows, in a 2-hour rated structure, which can be fully exposed, noting that there's some requirements for shafts, etc., to have protection as well. Once you go above that 85-foot criteria, you get into high-rise buildings. We can utilize a Type 4B and Type 4A, usually using the same structural floor system, 2-hour rated. As you get into that Type 4A, above that 180-foot height, we get into a 3-hour rated structural frame. So again, we're looking at these buildings comparably to Type 1B and Type 1A, as Greg mentioned previously. Really, the key part here is really on how much mass timber we can have exposed. We get into Type 4B, we allow 20% of the ceiling area, which is in relation to the actual floor area of a fire area or a dwelling unit area, or up to 40% of the wall. That's the current provisions. And as Greg mentioned before, as well as Ray, the new 2024 code changes based upon the RISE testing will seek to change those provisions to now allowing 100% of your ceiling area exposed. And that 100% is in relation to your floor area. So if you've got a flat ceiling and you've got a 3,000 square foot unit, you can have 3,000 square feet of exposed mass timber. If you have beams and things like that as well, then making sure that you now incorporate the area of those exposed beam areas. I'll get into a little bit more about that as well. And so again, just as I mentioned, sort of future code changes, this is excerpt from G14721, which is now have been approved by the ICC. This is going through the process of formal adoption to the future IBC 2024, which will flow down obviously to the California Building Code at some point. The changes basically has gone from that 20% exposed area at the ceiling to 100% exposed area at the ceiling. And so that will now start to see a much larger amount of exposed area in the dwelling units or fire area of office floor. Another aspect here is really just the separation between those areas. Part of the RISE testing sort of demonstrated that there's not a lot of benefit we had, an exposed area of wood on one part of the ceiling and another exposed area of wood on another ceiling. That 15-foot separation really had no impact on the fire dynamics of the environment, so they removed that provision when we have exposed areas at ceilings. Again, another provision here was really in relation to the benefits and obviously the conflicts of some of the protection provisions during construction. The new forthcoming code changes look to relieve the requirement for providing that 1-inch non-combustible topping on the floors during construction process. The committee found that during the construction process, a lot of these projects, they were putting the topping down, it got destroyed during the process, and they had to rip this up, and it created a lot of issues with the finished products of the material, also damage to the panels to remove during construction. So based upon the RISE testings, have found that the exposed floors didn't have a lot of bearing on the fire dynamics in the environment. So talking about the project goals and really sort of the basis of sort of how we talk about fire goals or fire performance as relation to goals for mass timber. I'm not going to go through these in too much detail. They've been covered in prior presentations, but obviously the big driver is really sustainable goals, and we've sort of taking ownership of a lot of those from a jurisdiction or from a client perspective as well. Cost is a big one. We're all running into cost of procurement of products, steel, concrete industry. Now the stresses that social and global impacts are having on the ability to build, as well as the ability to have labor on site and secure labor within areas such as the Bay Area. It's a high labor cost in the environment here. Aesthetics is definitely like, any architect that wants to sort of build with mass timber, their number one goal is really to expose that aesthetic of mass timber. It's a warm, it's an inviting environment, and it's really driven by the ability to expose your structural system now. We don't have to use high carbon offset or high carbon production products like gypsum or other things to encapsulate these members, provided we can work within the code or through a performance-based approach. And the construction schedule, obviously, as I mentioned, the ability to now look at kit parts or off-site fabrication, really getting factory workers in the factories in sort of clean and consistent and healthy environments to put these panelized products together and then ship them onto site where they can be craned up and erected fairly quickly. And it really is a much safer process and much quicker process to erecting these buildings. So really putting the focus on sort of getting back to these goals of projects of being able to expose more mass timber. So currently we're limited to the 20% of the unit area or the fire area in terms of exposed ceiling area. Most clients want to expose ceilings in these buildings. We're talking about even residential buildings or commercial buildings. Quite often we're doing a post and beam system or a point slab system. So not a lot of projects are using mass timber CLT walls on these projects. So quite often the driver is exposing the ceilings. We can expose the columns when we start talking about the beams and ceilings. It's important to note that we look at systems such as the rib deck assembly or something similar to that, where we have beams or purlins or girders integral with the ceiling. That's also counted as your surface area. And so it's important to sort of consider that when we're talking about 20% of your floor area. If you then transpose that your ceiling, it doesn't go a long area, it doesn't go a long way. And so it becomes a bit of a hurdle for clients to sort of understand if you've got a dwelling unit and you're going to protect the ceilings in your kitchen and bathrooms because you're required from a health department perspective. If you want to expose like amount of 20% of your ceilings and you've got sort of beams in that, it really doesn't go a long way in terms of your exposing your living room, etc. So it really defeats the purpose of having to have a lot of gypsum or other products protect your mass timber element and then a small little slither of wood. And it starts to also create deficiencies between your structural system of achieving 2 hours by char and then 2 hours by a combination of gypsum and wood. So it's simpler to look at this from a consistent perspective. Also, the benefit is really looking at the benefits of future testing. A lot of the NDS standards that we're using now are based upon the 2015 manufacturing standard. All products now in the industry are using the 2018 standard, and there's changes to that that are coming through now as well. It's important that those are using the thermally resistant glues. We no longer see delamination of the products. The product is burning and performing like a large sawn lumber product. And so we're seeing similar char rates from this testing. In addition to that, we can sort of build into that fire modeling, like the RISE testing showed, predictive modeling to show how the environment reacts to fire, how the contribution of the additional fuel load, and I'll go through that as a case study in a sec. So here's some examples of sort of graphics that we've used on projects to sort of convey, what this looks like in terms of the 20% exposure. And so here's a good case. This is a Type 4B building. Columns can be exposed per code. And now we're exposing the beams. This is a code compliant case. This is 20% exposed mass timber. So really you can have your main girders exposed. That represents 20% of your floor area. So you're not really getting a lot in terms of additional exposed mass timber in the environment. This is under the current code provisions. When we look at client drivers are saying, how can we go about exposing more mass timber? Then really if we start looking at 50%, now we're exposing all of our girders, but protecting the underside of the CLT. That can be either potentially lumped in the building, so we can expose the perimeter bays around the building. We've got a much larger amount of ventilation, or we're providing protection to inner bay areas which are closer to your core elements. And then really getting into kind of where we're heading, where the code is heading now, and where a lot of clients want to go with regards to protecting, their aesthetic drivers of projects is 100% exposed. And so the aesthetic quality that we get from these buildings, as well as understanding the fire dynamics and the fire concerns for these environments. I'll quickly go through this, but this is kind of just a framework of really establishing fire safety design for mass timber buildings. We go through table 601, which outlines the fire rating requirements for the structure, and the interim code now incorporates the new type 4C, B, and A provisions as well. For wood, we have fire resistance ratings that are determined in accordance with section 703, or through other methods of determining fire resistance through calculation or engineering analysis. And then we're going to get into 722, which really outlays the criteria for wood design, which then sends you to the National Design Specification, Chapter 16, which then also references Technical Report 10, which has some additional technical content for wood design. Chelsea already went through this, but really just to highlight the ability of mass timber to, one, obviously it burns, but it develops its own protective layer and char. It's understanding that it's a number of tests and historical, like mass timber, type 4 heavy timber, years of using the material and research has shown that there's consistent charring performance to these materials. So we know that we can calculate it. As we're getting into newer testing, like the FPL testing undertaken in Wisconsin, we're really understanding that as we get into larger char rates or larger elements with 3-hour test and more, we're actually seeing that the char performance improves markedly because we're getting much larger insulation provision from the char. So we're actually seeing reduced char rates when we get into longer fire durations. Really, the basis is we either have an exposed element and we're adding on a thickness of wood to accommodate the char, so we maintain the sort of minimum dimensions as required for the structure loading, and then we add on an additional 2 inches or 4 inches easily to provide your 1 or 2 hour rating. The other way to look at it is if we can get all of the rating provided by non-combustible protection, so we have the minimum cross sections required for structure, and we add on, let's say, gypsum board to give us a 2-hour rating to protect that structure. And then there's the approach that's really identified and outlined within the code is this hybrid approach of essentially 2/3 of the rating achieved by non-combustible protection. So it might be 2 layers of type X, 5/8 type X to give you 80 minutes, and then 40 minutes of protection provided by char. So you're getting a sort of a hybrid fire protection approach to elements. So there's all ways you can deal with this in terms of dealing with your rating for your primary structural elements and floor assemblies in a combination of fully exposed, fully protected, or hybrid of protected plus charring. It's important to note that when you're looking at, particularly in structural detailing, where we have, and we're relying on char performance of elements, is to make sure that we maintain that load path continuity at the end of that fire condition. And so we can see here we're doing a typical beam, column and floor assembly design. This might be for a design where we are a beamless system, essentially a point load system. We have floors come in that are being picked up by a column design. After 2 hours, we are obviously losing a cross-section of that column. It's important to make sure that we have enough connectivity and enough floor seat, so that column is still supporting that floor after a 2 or 2 hour fire duration, or even 3 hour fire duration for a type 3A condition or A condition. So again, it's important to sort of work through those details, and that requires a lot of collaboration at the early end with fire protection engineers as well as structural to work through the detailing of these conditions. If it's fully protected, if it's fully exposed, trying to work through these to make sure that we're detailing these connections correctly. An important point that was raised before is, we're still working to the 2018 version of the National Design Specification. It's 2018. And within that, we still have the char rates for CLT, which are based upon the ATF testing and what was also established through some NIST testing as well. A lot of that was where we had the glue line releasing wood that was releasing the glue, and what was dropping into the fire was adding additional fuel load, and it was also exposing new layer of CLT to char, as we said, accelerating char rates. That's picked up in the NDS and relates to an accelerated char rate for CLT compared to other mass timber elements. What we're seeing from the RISE testing, from the Forest Products Laboratory testing, other testing is undertaken in NIST, in Canada as well, in our CC facility, is that we're seeing char performance of CLT built to the new PRG 320 2018 standard, consistent char rates that replicate that of other materials such as glulam or DLT at the 1.5 continuous char rate. So I understand that there's work now at the AWC to look to amend the NDS standard to now look at CLT having a consistent char rate, continuous char rate that's similar to that of other mass timber products. There is the other way that can also be done as we go through testing. So manufacturers can test their products to show that within a 2 hour duration, they have a certain size panel. They can actually show that they have manufacturer generated char rates. So that's another way to bring in an actual performance of an element, but that ties you to that structural system or that structural product. Again, it was touched on before about the connection design. This is quite an important part of design. The building code has traditionally been pretty quiet on connection designs for steel and concrete design, and basically protect it the same way as you would protect for the rest of the structural elements. Wood would be a little more specific here because the connection design is a very important and critical part in the design. So there's new criteria that are now built into the building code that establish additional criteria for what the joint must meet. And so they're temperature criteria, which are similar to those that you'd see for a wall or floor condition for insulation criteria to avoid high temperatures to the wood so that we don't get degradation of the wood strengths. So that's around the 250 degrees Fahrenheit. We don't get at any one point increased temperature of 325 degrees. So it's basically an average temp of that joint criteria and a maximum temperature point. So this is really looking at steel joints, and we have wood that's supporting that. So at the moment, the ways of meeting those criteria for a concealed joint condition are 1, undertaking fire testing, or 2, undertaking a fine engineering assessment. And so that may be in the form of a finite element assessment. We can build this model up or build this joint detail up into a 3D finite element model, use testing such as the RISE as those fire conditions and ASTM 119 fire conditions to really understand what we need to do that joint to meet these thermal criteria. So part of this process is helping work through with jurisdictions to understand what these criteria mean and how we can show that joint meets those criteria or exceeds them. I won't go into furnace testing too much, but I think it's important to note that most North American manufacturers of these products have testing that relates to their products, and that will be ongoing, similar to other products like, you know, the concrete and steel industry. They've got testing and listings, et cetera, to support their products, and that will be ongoing for the mass timber industry. It's important to note that where we have different loading criteria that's undertaken for those tests, and the load conditions that are imported or used in that testing criteria may differ from that used in the actual load for the building, and to understand that we need to take that into account and working with the structural engineer to make sure that we're applying or validating the design as opposed to the testing criteria. So that's all accounted for again in the National Design Specification. So when we get into the value-added design process, is really looking at, okay, how do we now start to look at achieving some of these goals that clients want of exposing more mass timber, also dealing with a lot of the things that the industry just hasn't caught up yet. Things like the penetration details, edge of slab, header wall details, these things that we just don't have listings we can go to and say, hey, there's a listing, pick it up and run with it. So there's a lot of things where engineering judgment, all these details have to be worked through early with the jurisdiction to make sure that we've got a path forward. And so really looking at focusing on the sort of the IBC or CBC 703.3 or the 104.11, or in combination, these alternate means and methods, and really to focus on these 6 criteria of making sure that if we're doing something that's different from the code, or it's an alternate strategy, that we're showing that it's equivalent, if not better, in quality, strength, effectiveness, fire resistance, durability, and safety. I'm going to go through and try and get you to follow this, but really this is kind of like a sort of event tree analysis, or something we use to convey that with clients to help work through all the various different points that we need to work through with this system to get to that equivalency safety of aspects. So it's really just making sure that we're understanding all the performance requirements, the testing requirements that we need to address as part of this overall assessment, and then bringing in codes like the ICC Performance Code and other standards and guidelines in the industry to support a robust assessment. So getting back into that performance-based round and looking at the opportunity of using modeling. Here's an example where we are looking at the impact of a steel connector within a joint assembly. We want to understand, you know, what kind of protection we need to provide to that joint detail, how far we need to recess the pins, can we use wood pins, or do we need to use something like caulking or something to protect the steel elements, and what impact do we have an impact of thermal bridging, etc., like steel conducting heat and then causing charring of the wood joint details in close proximity. So this is a quick example of using a finite element model. It's only thermal, it's not structural, but the ability to look at this in terms of exposure to the standard furnace curve. We can then look at also using the fire curves that come from the RISE testing. We really understand, okay, we need to recess these steel pins, 2 inches into the joint detail. We need to put wood plugs at those joint pin ends to protect them so we don't get heat going prematurely into the joint detail. Really able to be able to work through to show that we have a joint detail that meets 2-hour performance. We also look at other fire tests that are done for like the framework test, the forest product laboratories testing, and compare the results of those testing with what we show from a predictive modeling to validate that it's providing relevant results. I'm going to go through a quick example. This is a project that we're working on in the jurisdiction of San Jose. It's a affordable housing project. This would be 12 stories of type 4B mass timber on a 1-story common podium, type 1A podium. Essentially, the project will be, as I mentioned, 2 towers, type 4B. This is a simple beam, column and slab system, so there's no beams in this system, essentially a point load or point supported system. The basis or the goals here is really to look at trying to expose more mass timber within this project to be able to show and enhance this within the living areas or dwelling units of the building. Part of the solution is looking at how we can firstly show the structural performance of the assembly is achieved and maintained in terms of the 2-hour fire rating. Looking at improving the compartmentation, because if we look at the statistics, most of the fires occur within the dwelling unit. Like most of those occur within the actual kitchen area of the dwelling unit. and then also looking at sort of what are the other issues regarding fire spread beyond the dwelling unit and the weak links. And quite often it's the unit door. We just saw the testing from the ATF testing, which indicated that 20-minute doors that performed fairly well, but that's 45 minutes beyond, or it got up to half an hour. We're really trying to improve that weak link at the door facility to make sure we're not getting spread beyond the fire unit of origin in the event that sprinklers fail. Here's an example. So basically, the photo on the left is Obrockie Commons. It's an example of the structural system that's been employed on this same project. The images on the left indicate the protection bands. We have 1, 2, and 3 represent the column lines. The pink color represents the exposed mass timber within the unit, and the purple color represents where we're providing gypsum protection, 2 layers of gypsum protection to provide a 2-hour rating to non-exposed areas of that assembly. And so it's an example here working with the structural engineer to understand where the weak axis direction or weak axis support condition for that floor slab is, provide additional protection to that to make sure that we maintain the structural integrity for 2 hours exposure to standard fire. And then also the pink areas which are exposed are still able to accommodate 2 hours of char performance and maintain that structural performance after that 2-hour condition. Again, the same sort of condition here, looking at the joint detailing. On the left is kind of that, not the same connection, but an example of that where we have this point type connection. Part of the detailing is working through understanding kind of where we may have weak links with a joint detail, or understanding what additional protection may be needed. So we run this through a finite element model to really understand, and what we represent here is essentially the top of that connection detail and then the bottom of that connection detail. We expose that to the standard fire furnace test to understand sort of how much heat we're getting through that joint detail. And it really helped us to understand we have enough mass, or we have enough protection to that joint detail. If we failed those criteria, such as the 250-degree criteria average temperature, we were able to work with the client to help them understand we need to add in additional gypsum, or maybe recess that joint detail in the floor assembly so it's protected by the concrete topping. So it's a good tool for us to be able to work through the joint detailing with clients and help understand that, hey, we need a little mass to this assembly, or looks like we're meeting those criteria. Let's sit down with the jurisdiction to work through how we're showing we're meeting those connection criteria. Again, some of you may be familiar with some of these details that you've seen through the jurisdictions. Again, as I mentioned, there's a lot of catch up in the industry in regards to things like head of floor penetrations, edge of slab details, etc. And so we're relying a lot on manufacturers of their products to provide engineering judgments that will also support our engineering judgments or alternate means and methods going through that jurisdiction. And so part of it is there's a lot of testing being done for the concrete and steel industry, and we're adapting those engineering judgments from all those products across to the mass timber industry. We're slowly seeing companies like Hilti and others starting to do testing of their products on mass timber assemblies only, and we should see those coming out sort of next month or two to better support edge slab details supported on CLT only without a concrete slab. But at the moment, we're having to sort of adapt assemblies that we have in the industry and adapt those to a mass timber only assembly. So here's an example of running through these, but it's important to work with the team early on. I know quite often these things are left to CD and figured out during construction. We're quite often starting to coordinate these early because we need the early coordination with a testing authority to get this to get these details figured out, and then work through the jurisdiction through an engineering judgment process to really nail these down so that we are not trying to figure these out during the construction process and really slow down things, because you're affecting concrete pours, you're affecting the ability for the facade assembly to go in place. It's really trying to front load these aspects early on and get them nailed down as part of the design. Same thing again with penetration details. We're starting to see more of these developed and available for mass timber assemblies only without reliance on concrete. So I'm going to quickly go through a process where we've worked through with the jurisdiction on increasing or exposing more mass timber within a commercial building. And this is similar to the process that we've undertaken for the McAvoy project, the 2 towers. Basically, the goal really here is to expose more mass timber than what the code currently allows. And obviously, the part of that is improving or providing mitigation measures to provide an equivalence level here. We're exposing more mass timber, so what are we putting in the building to address that increased fuel load or increased risk that's perceived by the jurisdiction? Understanding kind of this recent testing to support increased mass timber as well. And we're talking about the RISE testing, we're talking about the FPL, the Fast Product Laboratories testing, and testing has been done in Canada and Europe as well. And then really also bringing that all together in a performance-based engineering assessment to look at smoke modeling, predictive modeling, fire modeling, to understand how the structure, the impact of the increased exposed mass timber to fire duration, what does that lead to in terms of conditions within the environment, egress analysis, etc. And so really coupling that all together in a robust assessment. I won't go through this, but this is essentially sort of the ATF testing, which provides data that we can rely on and compare with as we get into predictive modeling. This is the FPL testing, which hasn't been covered too much, but this sort of identifies a test for a type 3A connection, sorry, type 4A connection. So this is really a 3-hour beam column connection. They showed that this beam column actually lasted in the furnace for over 4 hours. And this was designed per the NDS, under the NDS char rates, to maintain a structural loading for the 3-hour period. And it was still in the furnace after 4 hours, maintaining a structural load. So we start to understand as we get beyond that 2-hour fire performance, char rates start to reduce as we have a thicker protective layer to that wood. And then the RISE testing, which Ray had gone through in the past. So really pulling that all together, we sort of looking at the current provisions that where we are in the code that really relate on the NDS, or sorry, the manufacturing standard for CLT, which is no longer used in the industry. We're now using PRG 320 2018, so we've addressed the issue of delamination of those products. And so we get into use of thermally resistant glues, and then also looking to utilize the recent testing done by RISE and others to inform changes to the code. So we've seen the adoption of the Tallwood building provisions in the California code now. We'll see changes to NDS design specification for new char rates to CLT, and also those IBC 2024 provisions. Hopefully California will adopt those earlier. But this alternate means and methods process 104.11 provides an avenue to be able to bring in that testing earlier as a full engineered approach. Again, part of this is understanding the results, data that's come out from this testing, and then ability to replicate and model that when we're looking at a commercial building or a residential building. So essentially understanding where we have exposed mass timber within a building, how much we're exposing, what are the compartment dynamics, how much ventilation we have, and then build that into a model with regards to fire cases, fire load duration, and how much thermal exposure, temperatures in those environments. And we can compare that against the RISE testing and other tests that have been done to validate the predictive modeling. You're really sort of bringing it back all together as approach of really how we showing that we're allowed or able to expose more mass timber. Obviously, we're part of that is improving mitigation measures. Maybe we're bulking up the sprinklers, improving the compartmentation within a unit, upgrading, providing additional smoke detection within the spaces, or additional provisions for the fire department to be able to access the building and undertake firefighting operations. The RISE, the testing that's been done to support the improvement of products in the fire industry, the testing as well. And then we're looking at the performance-based design. We can do smoke and heat modeling to understand the dynamics of the environment, egress modeling to show that we can get people out, and also making sure that we're supporting fire department operations. And I won't get into sort of too much of the minutiae there, but that's sort of really encompassing this whole thing into an overall engineered approach to work through jurisdictions. So that's where I'm going to leave it. I think one of the topics I didn't touch on was really the safety during construction, but maybe we can hit that in the panel if someone has a question on that as well. Thank you.
Great, thank you, Bevan. Okay, I'd like to invite Bevan up and Chief Greg. And we also have 2 other panelists for the next hour. So I'd like to invite up David Bassinger. David has over 30 years of professional experience. I'd also like to invite Darren while I'm reading this. David has over 30 years of professional experience associated with architectural design and code plan review. He has a Bachelor of Architecture from Cal Poly University at SLO and is licensed architect in California, Nevada, and Arizona, Utah, Colorado, Washington, and Hawaii. Mr. Bassinger started his own code consulting, plan review, and inspection firm in 2006 and has reviewed complex commercial projects and a variety of multifamily residential that have included office campuses, industrial plants, and high-rise construction. Over the years, he has managed teams and plan review and inspection services for numerous jurisdictions across 5 states and has served as acting building official for the city of Fremont and Mountain View, as well as been a regional manager over 3 offices in the state of Arizona. His firm is active in ICC code hearing and adoption process and provides code classes across the nation for every code or system. Thank you, David, for joining us. Also invite Darren Ranaletti. He is the Policy Director for Housing Security in the Mayor's Office, City of Oakland. Darren Ranaletti has 25 years of experience in fields of housing, city planning, community development, and real estate. He currently works as the Policy Director for Housing Security in the Office of Oakland Mayor Libby Schaaf, where he serves as Senior Advisor to the Mayor and leads interdepartmental initiatives and public-private partnerships to promote safety, healthy, affordable, and stable housing in Oakland. Prior to joining the mayor's team in 2018, he worked in the City of Oakland Planning and Building Department for 16 years, most recently as the Deputy Director, where he oversaw the land use planning functions of the department, including development policy and major development projects. So for this panel, I have some questions prepared, but I'd also like the audience, if you have questions, to think of them, any burning questions. But let me pull them up quickly. Right. So I'd like to start with Darren and David, since they just joined us, hear a little bit more from them. So let's start with Darren. You work in the mayor's office on housing policy. Why are you interested in mass timber and construction innovation?
Well, thank you. I bring a little bit of a different perspective to this as a housing policy person. I'm not an engineer, not a fire safety specialist, but we have a housing crisis here in the Bay Area. I think you all are aware of that. And it is having a tremendous, devastating impact on Oakland. Housing is expensive for a lot of reasons, but one of the reasons it's so expensive is it's so expensive to build. Construction costs in the Bay Area have more than doubled over the last 10 years. In Oakland, rents have increased 70%. Meanwhile, incomes are pretty stagnant. So, this isn't just a theoretical exercise. This is life and death. We've got a huge growing situation of people who can't afford to live in homes. And so we have people experiencing homelessness. And in Alameda County, in the last 3 years, 800 people who are experiencing homelessness have died. Okay, so this isn't just about making it easier to afford, it's about keeping people alive. So I really approach this from a perspective of what can we do to reduce the cost of construction so that we can deliver housing at a more affordable rate, both market rate housing and subsidized housing. And new technologies like mass timber and other innovative construction techniques are totally essential in that.
Thank you, Darren. Okay, so David, you're architect, principal, CEO at Schum's Coda Associates. Can you describe the service that third-party plan review companies are providing for cities and what the benefits and drawback are for both the jurisdiction and the submission teams?
Well, our firm basically consults to cities on an as-needed basis for new technologies like this. So that's kind of our sweet spot in terms of sometimes staff isn't as familiar with new products like this. We have a team that goes across the country, is involved with the code hearings, does a lot of teaching on codes and the new code products. So we can bring some of that expertise back to the city staff, give, feedback in terms of how the process was developed, products, testing, all the information regarding implementation of the new systems. To their staff, we can also help with the reviews or the inspections as well. So I think it's a benefit in terms of, really just in terms of difficult to find all the qualified people for some of these newer products. Probably the drawback is, we aren't always, as integral at the city side level. We don't have all the different departments coming to us and talking to us. So it really is important as far as the communication goes with us to get our message out in terms of what the code minimums are. And if we can't do that, then I think that's a drawback, where there's sometimes a disconnect between a building department or an inspector or something like that if we're not all on the same page with that initial discussion.
Great, thank you. Okay, another one for Darren, more about Oakland. What has Oakland done to support this sort of construction innovation?
So in 2016, Oakland Mayor Libby Schaaf convened a group of folks called the Oakland Housing Cabinet to really tackle housing affordability in Oakland. And there's a long list of strategies as part of that effort. And one of those was around tackling the cost of construction through construction innovation. So we were really tasked with how do we do that from a city perspective. We don't control the cost of lumber or the cost of labor to an extent in the city, but there are things under our control. We have local regulatory authority, the codes, we also have our processes. So we embarked on an effort to understand how we can be more innovation friendly. And we did some research based on a grant that we got, conducted surveys, focus groups, analysis, and came up with some recommendations for how we could improve our codes and our processes, and we're in the process of implementing that. And I think we've learned a lot, and we've got a long way to go, but I think it's essential. And if there are other jurisdictions that are interested in doing something like that, look for opportunities to do that kind of research, talk to your local stakeholders, look for grants, because I think there are things that local jurisdictions can do.
Great, thank you. Back to David, talking about this review process of mass timber projects. Can you speak a bit about the projects you have reviewed, focusing in California, but around the country as welcome as well, and some of those challenges from your perspective of the review process?
Well, we've done a few here in California, but they've been really more the low rise. The Microsoft campus that was brought up earlier is a two-story building that's been completed now. I think in terms of, with every jurisdiction, it's a process of a new product, getting used to what the minimum requirements are in that code. And we have a whole new code section coming up with all these 4 A, B, C categories. So it's, I think that's the bigger issue in terms of trying to get the projects through. And really what you'll find is in California in particular, but everywhere, is that the architects and the engineers and the owners really want to stretch the boundaries. Like Bevan was saying, we have the code section, which is the prescriptive minimums, but then we always get into, but can I do this? Can I do that? What alternative materials and methods approach can I get into? And that really tends to be a much larger issue at the cities, because everyone's always pushing that envelope and trying to do a little bit more with the new product. Certainly from an architectural background, I can appreciate the architects want to expose a lot more of this CLT product. It is really inviting and nice looking. So, the Microsoft campus could do that. It was a 2-story. It was really not a bigger issue. As we start to get into these taller buildings, they start coming in, and they're starting to. That'll be the big push, I think, as far as Bevan was saying, trying to expose more and more of that wood product.
Great, thank you. And opening up a bit more to the rest of the panelists, Bevan, you talked on this a bit, interfacing with both fire service and building departments. Anything to add on challenges you see for jurisdictions in reviewing these and advice?
Yeah, I mean, just adding to what David just mentioned, that whilst mass timber, by virtue of heavy timber, is not a new kid on the block in terms of construction methods, the new engineered products we're seeing, like CLT, MPP, they are, and they're foreign, and also the desire now to sort of expose more of these mass timber in building applications that go beyond 85 feet. So there's a lot of new ground here. There's a lot of new provisions in the code, and there's also a lot of research that's been undertaken to sort of get to this point and where the code changes are going. So there's an education aspect that needs to happen, and I think part of that is early engagement with those authorities to, one, create an equal playing field or ground to work from, so that there's a clear understanding of kind of what research was undertaken to get to these code changes, what they mean, sort of the basis of a lot of the ad hoc committee discussion process, bring them into play with where that went and how we got to that decision process, so that they're aware of what decision-making process the basis of getting there. So part of that is a very early engagement to work through the jurisdiction. Quite often we've actually spent not talking about a project, is just do a quick presentation, the whole group, on what those new changes are, how they came about, and how they're now being applied to a project, just so that there's an education process. So it starts off very early, quite often not even specific to a project, but really the ability to educate everyone on what these changes are. And I think that needs to be a continued process as we adopt new provisions. Industry's progressing very quickly, and a lot of that's to meet sustainability mandates. And I think we need to be all on board and making sure that we're all aware of why this is happening and how we're getting there.
Great, thank you. All right, so this leads into my next question for Chief Greg here. Are there modifications anticipated for the 2022 CBC with regards to the suite of tall mass timber provisions here?
No,
There you go.
because we already brought it early, so there were no changes at the model code. So the only change is changing the font from italicized to normal font.
All right, thank you. So I'd like to now open up, I have more questions prepared, but if there's anyone who has questions, or even panelists who have questions for each other. Yes.
I'm going to tie on to that conversation about the IBC 2024 provisions that have just gone through the formal finalization process. Curious on what California's thought process of those provisions. Any discussion happening yet about the adoption process?
We have not had the discussion on that. We're just starting in our work groups for the intervening code cycle, and maybe something we consider.
Any other questions? Lisa, yes. Okay, I'm going to repeat the question with the microphone. So the question is, has there been any consideration to changing the CBC provision that you can't double dip in that heights and areas when you have sprinklers?
That's actually a bigger conversation about for all the type of construction, not just that. There have been discussions. We have not moved forward with that. That will be a much larger debatable topic.
Thank you. Yes, another question. So the question is there, with the new tall wood construction types, type 4A, B, and C, is there any thought to the fire truck access for the buildings?
No, it will be the same because it's still a building. Even we're looking at comparative even with type 1, which is non-combustible, we still have our same requirements for fire service to get into the building.
Yeah, just one addition to that is that there's no real changes to it, but there's one aspect in terms of the California Fire Code hasn't been updated to include these new construction types. And so when we look at fire flow to a building, it still considers type 4 construction, which requires you to consider the full building floor plate. So quite often when you start going up in higher levels of a mass timber building, 4B, 4A, you'll quickly get to the maximum required fire flow for a site. Typically, when you look at equivalent high-rise buildings such as a 1B or a 1A, you're only required to look at the largest 3 floors, I think, in terms of the area. So there's a difference there in terms of you are still having much larger fire flow requirements going to a high-rise mass timber building.
Great, thank you. All right, so I have another question for Darren. You worked in the planning and building department before joining the mayor's office. Do you have any examples of how you processed a project with new technologies?
Yeah, I can think of one that was actually presented earlier, Project One by Social Construct. Michael Yarney, right here in the audience, had the pleasure of working with him. And I think really underscores Bevan's point about early engagement. So Michael came to the department early on and said, hey, I want to try these new technologies. He's doing CLT and also prefabbed, an innovative prefab MEP component system. Because of the interest from a larger policy perspective and the interest in the mayor really pushing this, our office, the planning and building department worked with the mayor's office, and we met with Michael, and we actually went to the warehouse in San Francisco, brought a bunch of Oakland building plan checkers and inspectors to look at the technology. I think, 10 years ago, the city would have just said, apply. And then, we would have received something and it would have just said, submit a whole bunch of documentation, and it would have just been months and months of back and forth. But this allowed them to go early on and see it in person, understand how it was manufactured, how it was installed. So when we got to the plan check and inspection process, I think it went pretty smoothly, right? Yeah, Michael's giving the thumbs up. So that early engagement is critical. But I also, building departments are really hurting right now. We're totally short-staffed. Because of COVID, we've had to go to an online permit center, which was great because it accelerated the move to more accessible for our applicants. But now we've opened up the in-person permit center. So we've got 2 permit centers. The Great Resignation has really hit us. We've got about 50% staffing. And so we've got more work for fewer people. Most building departments are set up to be cost covering through application fees. So literally, we can't afford to do all that work that we did with Michael. So we have a new process. It's a pre-application consultation process. So we can afford to do that early engagement because people pay us to do it. So they pay an hourly fee. Maybe it's just an hour trip to San Francisco to look at the warehouse, or maybe it's 5 hours with some follow-up documentation. And that time and money spent then on the designer and applicant perspective saves time and money down the road. And so that's an example of how we've been able to afford to do that important kind of consultation, because with these new technologies, every day there's going to be something new. And so being able to have that talk back and forth. And so if you're in a local jurisdiction, you don't have that, then look at your fee schedule. You might need to adopt a new fee. That's what we had to do. We had to build in a new fee into our fee schedule. That was that per hour consultation fee.
Great, thank you. Really informative. All right, David, from the review process, incorporating these new materials, challenges kind of generally, thinking about innovative materials, what are the challenges you face, and any advice on that?
Well, for the CLT product, as Bevan indicated, a lot of the joint things haven't been tested. That's really the bigger problem. Most of the building departments, like I say, being short-staffed, they're looking for manufactured product listings on these new products. So having that is a huge step forward if you can get that type of product in place, because it's just, there's a report, there's findings, there's what you have to do with that review process. Pretty straightforward. When you get into the ones that aren't listed, it gets a little more ambiguous as to how you're going to approve that. I think we also fight some of these products on CLT are proprietary. That basically ties you in. You have to build it exactly that way. Any modification voids the proprietary listing, and so you get into, again, you're in that gray zone of what works, what doesn't. And then, third is really the what we've been talking about, the AMMR sort of engineering judgment sort of thing. those are always kind of a hit or miss sort of thing. It's probably dependent upon how well you present those to the building departments, building officials that are making decisions. They have to be able to be kind of take a lot of that engineering logic and testing and stuff and really kind of bring it down to just a general level where we can talk about it just as a conversation piece and be able to understand it. A lot of the architects and engineers are not really great at communicating that way, so it really sends the process off in a longer timeline, and that just will kill a project if you have a 2-3 month delay on getting something approved. So those are the bigger issues I think starts to see it. And the other part's going to be as we get into these new materials, and particularly at the higher heights, you're going to have a lot of building departments coming to the classes that my guys teach nationally, and it's always you go to the class one week and the next week you've got a whole new list of comments you want to ask the architect or engineer. So we really need to, on our side, watch against that as well.
Great, thank you. And Bevan, any comments on that? Processes that you've seen work well, both from the designer side and jurisdictions you've worked with?
I mean, I think David hit the nail on the head, really, in terms of that engagement process. I think part of it is really, one, as I mentioned before, just the education process, making sure that what you're trying to work through with the jurisdiction, there's a level of education there helping them get up to speed with these new provisions in the code and the testing that's behind it. But also, again, is the engagement process with the authorities and making sure that there's a lot of testing, a lot of information, a lot of data, trying to distill that down to a level where you can have that conversation, there's an understanding, and it's a platform where you can sort of have to and fro questions and work through that, because as I mentioned at the start, wood burns, and these engineered products are a different beast, but there's a lot of information that needs to get to a point where we can start to distill some of those concerns and work through them. And quite often when we're sitting out the jurisdiction, the first question we ask is, what are your concerns? How do we start to work through those?
Thank you. And Chief Greg here, looking forward even to new materials, how is the Office of State Fire Marshal looking at things like building battery technology, things in the building code that don't necessarily even have a history of fire data? Are there tools, resources that fire services should be aware of?
Well, it's interesting you brought up energy storage systems, because that one's a little bit of a different creature. When you're looking at the regulations, especially at the ICC at the state level, we try to bring them up to standards, not telling people how to do it. There's standards that they have to meet, which means a lot more flexibility of materials and new innovations. Energy storage systems, that was a new battery technology, and when that came out, we found out the regs didn't work at all. They were built for lead acid batteries, so they did not address the hazard if you met the code. So there's been a lot of work on that, and the new regulations working with UL that we have in there now are open for new technologies to address any new hazards that are identified there. A lot of the problems with the lithium-ion batteries is a big example, because that's becoming the common one, is the manufacturing standards. Because the hazard isn't the hazardous material as it was traditionally. Now it's the energy. So that whether it can pass a UL 9540, and then we're looking at the UL 9540A, are the significant standards of identifying the hazard as it grows, because there is a hazard there, but it can be mitigated. And that's a whole different discussion on energy storage systems.
Open a can of worms. Any other questions from the audience here or panelists? Quiet crowd. Yes. So that's a good question. So the question is, in Ray's presentation towards the end, we saw the rehabilitation of charred mass timber. So they removed it and then they screwed in a layer, but then they glued it and they removed those screws. And the concern was those screws and the heat transfer. And is that going to be a concern in nail laminated timber? Bevan, do you want to take that one?
I'll jump on that one. I mean, obviously, sort of any steel or metal product, fasteners, etc., within wood is a concern because it creates a conduit or bridge for heat to transfer further into the element, right? Now laminated timber, or by virtue essentially, is the boards laid on end and then nailed through or screwed through. The intent here is that the nailing of those boards is outside of your char zone. So essentially, if you're required to have a 1 hour performance, you may have 1.5 or 1.5 inches of char zone. So you'll make sure that your fasteners are outside of that char zone, so you're not impacting the structural integrity of those elements. So basically, it's just the same process of understanding what element or size that element needs to do the structural performance, and then what are we adding on for that sacrificial fire layer.
Thank you. Other questions? Great panel up here. Yes. So the question is, it was discussed that manufacturers provide char rates. What's the standard process of obtaining those?
That's a good question, Cody, and I think it gets back to what Dave mentioned about a lot of products being proprietary. And if you go the way of CLT manufacturing their product, you're kind of stuck to it early on. But I think and one example is Frere's Lumber, who make mass plywood MPP. They've done some ASTM 119 testing and have shown that they've got a very dense product, that it actually shows a reduced char rate. Basically, they're able to achieve a thinner panel to get a 2-hour fire rating. So they have those tests available, and so you can download that, I believe, from the Frere side or inquire from them, and they can give you their test report from their panelized product. Again, just by the proprietary nature, it's you can get it directly from them. I don't think it's available directly on the internet, but there's ways to get that information, and we can definitely help provide a conduit to that. Yeah. The question was, is that a verified test standard approach? So yeah, it will be at a nationally recognized testing laboratory.
And I will note, WoodWorks is collecting all the fire tests that are available, and we have an inventory on our website. So it's not the test data. You have to go to whoever did the tests, but we are collecting that, and we have listed that inventory for assemblies of floors, walls, penetrations, and also some connections. So that is available on our website for free.
A really good thing on a new industry, because that's going to be the weak point.
Yeah, and that is our goal at WoodWorks, is to help remove barriers and just provide that information for everyone. So Chief Greg, I have another one for you actually. How are fire services adapting their processes to incorporate new or different types of fire risk that come with construction innovation?
Well, just like anything, a lot of it will be education. Whether we're talking about energy storage systems, which we have a lot of training that goes through this state, Cal Chiefs, FPOs. There's at the national level, especially with energy storage systems. We have some new training programs that have come out for A2L, which may be coming. It's actually already here in small quantities for the flammable refrigerant that's used. Just like anything else, it's training. You have to understand what the hazard, so we're not putting our employees at risk.
Thank you.
When you say local government asked to accelerate the adoption, and at that one I'll point, it was our state government that did that. This is in the governor's office and the assembly, and that is driven on the climate change and the I think all the things that Katie presented to meet the goals that they believe will assist this state in our carbon neutrality.
Any other questions? So we have an online audience with us. So mostly for our online audience, Bevan, do you have any advice to designers? Best detailing practices or anything else to streamline the review of their projects?
Hey, yeah, I'll give you a call later on. I can help out. I think part of it is WoodWorks is as a great resource for online information. Whether it's sort of acoustic details, fire details. There's it's a wealth of information there. Obviously, with mass timber and the way that we're using this product in the industry, every project is different. I haven't worked on a mass timber project yet where there hasn't been something that's exactly the same. So there's a lot of change. Part of it is working early on, and I guess it starts to front load your design process a lot more. Particularly, it's the same thing you do for any sort of modular construction or kit of parts or design for fabrication, is that you got to front end a lot of those detail aspects earlier on. So during schematic design even, or even like detailed design phases in a project, you're starting to work through a lot of things like how do we connect the facade assembly to the edge of slab? What are we looking at for some of these penetration details, and starting to work through some of those things, because one is probably going to be a longer time frame to working these things out with regards to getting some reports from Hilti 3M or STI or other sort of manufacturers of those products, working through how that ties into facade assembly and the required movement of that facade assembly. And I think it again is incorporating designs with the MEP and things like that. So again, it's having those earlier conversations earlier, making sure you're bringing your consultants, the acoustic, your MEP, fire consultant earlier on in the project to help work through those details. So it's probably a little different to what you would do from a traditional concrete or steel building, because you've got a lot of things in the industry that you can just rely on and just, hey, pick that one off the shelf. It doesn't exist yet for mass timber, and you need to sort of start that earlier coordination.
Well, I'd even add on to that. I mean, I also need to bring that whole design team back into the jurisdictions and have those conversations on the design development, because that's what saves you time on the permitting and inspection process. We've done a lot of those projects together where, it's been 18 months or 2 years before even submittal, where we're just working through details and code issues with the design team. That really streamlines it. I mean, it streamlines the back end process. It still takes a while to have all those conversations, come to some with the jurisdiction.
Thank you. Maybe question probably for both Bevan and David. I think something interesting with CLT is, I think I mentioned this early on, where it's prefabricated for a specific project, right? Each of these panels is made for a specific location on a specific project. When is that CLT released? Like, someone has to purchase that CLT, it has to all get made. And how does that work with this approvals process? When are they saying go on the CLT panel? Is it approved process? Are they taking a leap of faith?
Depends on the contractor, I think, how fast they're moving. In a perfect world, I mean, we get through the approval process and the product's developed and built, and there's usually a good line in terms of product sort of labeling, so you can almost follow it nowadays from factory to the field. But we've been on many projects where we're kind of as opposed to design build, it's build design. That's a tougher one to deal with. So there's probably a lot more faith on the jurisdiction side in terms of the at-risk process, and you're going to go ahead and we're going to assume it's going to work this way because we've talked through enough of the basics. But it really puts a lot more back on the developer and contractor.
Yeah, I mean, the basis of the question, I'm going to push to the GCs in the room, but I think there are some at-risk components to the process, particularly as we get into the alternate methods and sort of wanting to expose more mass timber or doing details that there are no UL listings for. It's not a straightforward approvals process. That component does put the project at risk somewhat when you're trying to get a lead time of securing panels, and it's a 5-ply assembly and the 2-hour fire rating of that is fully exposed. It's an easy question. It's just like, okay, we don't agree with the AMM or we want to fully protect it, but it could have an impact on the size of your panels or the detailing of connections, and that starts to sort of impact your construction time frame or your procurement process. So again, by trying to front load that, work with the jurisdictions, have the design team at the table and coordinate those aspects and really get the jurisdiction on board, and having, you know, some form of agreement to create security for the GC to go ahead through that procurement process, that's inherently important. You know, until we get further and further through the industry and have got more information to rely on, it becomes a much more streamlined process. You know, we're kind of at this fuzzy phase of frustration a little bit here that we're all trying to work through.
Yes, Dave.
Add on to that, because in our research we found out another piece to this is financing. And so you have some lenders who aren't familiar with how off-site construction happens and in what phases, and with construction draws and when payments are made. And some just, it's just outside their typical, you know, pro forma, so they're just not going to do it. So in addition to the construction industry, it's also around, you know, investors and lenders and financing, getting more comfortable with different types of ways that buildings are built.
Yeah, we've seen that on the insurance side too, and we have some resources on
Is anyone from the insurance industry here? That's a stakeholder that needs to be brought to the table early as well. And yeah, I think there's definitely conversations with the industry that need to happen and bring the insurance industry into the fold more, because there's still a education and understanding gap there in terms of how these buildings are insured, how builders risk insurance is procured as well. And so I think that's another conversation that's happening but needs a little more acceleration.
Any other questions, audience? Yes. So the question is in regard to the testing that we saw improve char rates over time.
Yeah, it's a good question, Cody. I'm actually going to be up at the FPL test lab later this year to talk through kind of the RISE testing and FPL testing, and kind of what are some next steps that the industry wants to do to bridge some of the gaps that we currently have, and obviously inform kind of the next process for ad hoc committees and things like that, changing mass timber. So I think FPL testing, along with other stuff, will start to inform those conversations. In terms of using that information, it was there to advise and inform the Ascent project, which was a type 1A, type 4 heavy timber building, but the same sort of building topology as a type 1A. So really they designed a type 4 heavy timber to achieve a 3-hour rated joint detail. So that test was specific to inform that project. But the outcome from what we can realize in the industry is understanding that, okay, when we start getting beyond that 2-hour rating performance and these wood elements exposed 2 hours and more, like a tree, you know, it chars pretty heavily, and you start to protect that in the wood of the element, and we start to see degradation of those char rates because we've got a much thicker char protection. So I think that, and we're starting to see, you know, PRG 320 2018, PRG 320 2018, a lot of the performance and testing of those panels, showing that we can actually now start to use the continuous char rates as opposed to the old char rates for CLT. We're starting to see, you know, more and more data in the industry from actual testing and research to inform and update the specifications and design guidelines that we're using.
And I will add on to that, because the heavy timber has been in the code for a long time, because we know that even though it chars and burns, it still has its structural ability inside. We absolutely have to see that CLT performs at an equivalent level, but then you also look at steel. Steel, a beam can expand a foot, 2 foot, twist. That's why we fireproof them. They don't add to the fire load, which is different, but it is something we have to look at, and just more information.
I'm going to add on to that again, is there's this perceived notion in the industry that, you know, if we have a fire in a concrete or a steel building that's obviously fire protected, that, you know, the fire happens and then you just put on some more fireproof and away you go. It doesn't actually, not the effect, and there's a lot of focus on what happens to wood timber buildings after fire and how do we fix them. The same thing happens with steel and to some degree concrete buildings. Steel buildings, when exposed to fire, the beams still heat up and you'll get distortion of those beams. You'll still have to either replace them or fix them in place, not just the fireproofing. Likewise, concrete reinforcing steel gets heated up. You may have to go through and test it to see how much degradation it has and potentially replace part or that column. And so those become actually much major concerns in terms of replication or replacing those structural elements. Wood, as you've seen, it can be fairly easy fix because you're replacing that sacrificial layer of the wood, not the structural component.
Yes, Lisa. Yeah, so let me distill that question possibly, see if I got it. So the question is, we know through all the testing that we saw today, there's a conservatism within the proposed or the adopted Tallwood provisions. We've also heard that, the cost of construction is really high. And so can we reduce that cost by, changing some of these provisions in the future?
I will answer that, and I'm going to say cost is not the main driving factor on that when we're looking at the safety, because I don't want to save money up front and have the building collapse. So is it a conservative viewpoint? Yes, it is. Absolutely. We wanted to be something that was conservative, that we were comfortable with the safety. Have they been reevaluated? Yes, they already have. We already have changes in the next edition. The height and area were already being discussed again. Now, it was decided fairly overwhelming, not at this time. We need more data. But just like we have reevaluated the height and area of other types of construction that have changed over the years. Yes, that is part of the code process.
Yes. A question about mass timber and termites.
Good question.
I don't know that I've heard of. I mean, we're in a high termite area pretty much across the U.S., but I haven't heard of major problems.
Likewise, I think it's a little out of my topic, but the topic comes up in a number of conferences in the past. I think part of it is like any wood detailing, is to keep it out of the ground, and so which is a common approach. You're building on either podium construction or you've got concrete platform. You're not extending the wood down into foundation design. So I think a part of it is that detailing one from a protection from external conditions, water intrusion, as well as termites and things like that. So part of that is really the detailing that happens from the exterior facade and at your grade level.
Any other questions? Oh, we have some from online. Excellent.
The phone a friend.
This is the online. To all panelists, what hurdles do you see for adoption of mass timber for Los Angeles, city and county, jurisdictional context, etc.?
Well, I'll start representing the state fire marshal. We look at the minimum codes across the state. The locals, per statute, have the ability to have ordinances that are more restrictive. At that, it becomes their issue, not ours. We look as much as we can, a fair minimum safety level playing across the state.
We're working on a mass timber project with the LADBs at the moment. My understanding is that they've now adopted the California provisions of the 2019 interim changes, and so prescriptively there's a pathway there.
statute, they adopt it unless they amend it, and they can only be more restrictive.
Great, thank you. This is an interesting one. Has moisture content been considered in fire testing of mass timber? Do affected elements have significant shrinkage during fire events that are considered in connections?
Oh, that's a tough question. I mean, I think as part of the mass timber testing, I think obviously the elements are in a laboratory environment, and so there's some conditioning that's involved there. Typically, mass timber elements will, from arriving on site to being installed, will swing from say 19% to 12% moisture content. So in terms of the conditioning of those elements, it goes through the same process so that the testing in the laboratory facility replicates the end use condition or in service condition for an exposed mass timber element within a building. So the intent there is that you're replicating what will realistically be within a building environment. In terms of the moisture, unlike a product like gypsum, which actually relies on moisture within the entrapment of gypsum to actually move through and provide protection, wood, by virtue of its high carbon content and ability to char, that's the fire-resistant component of wood. So the moisture content does have a slight bearing on char rate performance, but again, we're looking at a long service life condition, and we're around that 12% moisture content, which is what the testing is based on.
Great, thank you. This is a fun one. Is there such thing as pre-charred mass timber members? Is there efficacy to reduce chances of members catching fire with this? Something similar to Japanese sujiban.
The shiguruban treatment. There is, I think that product has some testing performance. Predominantly that's associated with surface flame spread characteristics as relates to using that component or that product on the exterior of buildings to meet the exterior facade requirements for CPC and NFPA. There is, potential for looking at pre-charred elements to provide additional char, but I think there needs to be additional research happen. I think obviously having charred elements inside a building interior environment may not be a suitable use of that approach, but potentially it has an exterior element where you've got large mass timber exterior elements and you have them pre-charred. You've got to also deal with other aspects, not just the fire component, but also weathering, water intrusion, termites, and any other thing that may be an impact there. So there's a lot of other factors that need to be considered further for that to be a viable strategy, but we are seeing it employed on smaller scale projects.
There's a few reuse buildings where they've had a fire in a warehouse and they've repurposed it as a restaurant or assembly space. So you do see it where it's already in place.
I can see it used as aesthetic purposes to change the fire rating. And then you get into more, well, how much was it charred?
Thank you. All right, so we have 10 minutes left or so. Any closing remarks from panelists? Ideas on, what the future holds for mass timber, advice, questions to leave with our audience? Anyone can start. Oh, quick question. No problem. Yeah, so I think this is a question for Chief Greg in terms of the facades of the structure. I think you might have mentioned this.
If you go to the type 4A, it has to be non-combustible for the exterior. For the other types, it can have a wood exterior, but you still have other parts of the code, which aren't my specialty because they're not the fire issues, but we're looking at the weathering and all the other components that they would need to comply with.
Yeah, so just adding to that, you can have an exterior combustible cladding up to 40 feet between 40 feet and 60 feet. It needs to be fire retardant treated. Above that 60 feet, you can't have any exterior combustible cladding components. There's also, and what probably relates more to the Grenfell cases, the components within the wall assembly in terms of combustible components inside the wall assembly, and there's the NFPA 285, thank you, that relates to, the membrane components, etc., within the wall assembly. So there's, I think the US has a good grasp on the restrictions for exterior wall provisions, and so, but again, in terms of expressing mass timber outside of your building, maybe it's in the form of structural elements of mass timber. Type 4, Type 1A actually does have some provisions where you're able to do that, and so through alternate means and methods, there may be a way to adopt those same provisions as for Type 1A and apply those for Type 4A or Type 4B.
One construction, there's some allowances for some of the
Combustible construction.
combustible facade, yeah.
Great. Any closing thoughts? Start on the end, Darren.
Guess just from my perspective in affordability, in the Bay Area now, it costs about $750,000 per unit of new multifamily housing. That's insane. This is totally unsustainable. And so I think, we should design and build buildings to further societal goals, right? And so, 100 years ago, they were unhealthy and unsafe, and now they are healthier and safer. And in the early 2000s, with Cal Green and green building, we started doing things that previously people thought was totally unsafe. So, we've got gray water now and recycled water, and the plumbers were like, "What? That's totally unsafe. Why would you do that?" And we have that now because we realized that we have all these other goals. And so I think affordability is the next frontier. So I think cost is going to be increasingly factored into those considerations, and both at the local and the state level, because we've got to do things differently.
Thank you.
We're going to see a lot more of the Type 4C and the B and A as well, but I think certainly the 4C is the push right now because it's got so much more of the wood exposed. That's really what the architects are pushing these days is aesthetics. See what we get with the bees. It's going to be.
I just want to sort of, again, the comment that I made at the start of my presentation is that I know that a lot of you are very busy, a lot of you are very short-staffed, and I just appreciate the time taken out of your day to come here. And I think education is key, particularly when we're having these conversations about a new product, new code provisions, and a lot of new research and information that's happened. It's only more and more of it's going to happen as this becomes a massive driver to meet a lot of goals that are bigger than just this mass timber aspect in terms of sustainable goals and climate change. So there's going to be acceleration here. There's going to be new products coming in the market. There's going to be new drivers to advocate more and more code change to really support the bigger goal of climate change. So education is key, and we've thoroughly enjoyed working with a lot of jurisdictions to help them get up to speed with these provisions and work through not just a project. So I'll put my hand up to say, hey, if you want to know more about mass timber, and definitely working with groups like WoodWorks and the panelists here as well, happy to come along to your jurisdiction and give a little presentation or whatever, but also an opportunity to ask questions and sort of how we've worked through various things in the industry or where things have come from as part of these new mass timber provisions. So please reach out to me. I'm more happy to come in and help talk through those aspects.
Well, Tallwood buildings, it's here. It's in our regulations. You will be seeing more of it. Do we still have issues? Yes, we'll be working through it. There will be more testing and especially more assemblies. It will become easier, but right now we're in that learning curve. And it's not something to avoid, something to learn.
Thank you. Thank you to all the panelists here. Thank you for joining us.